आज के हमारे सब्जेक्ट स्पेशलिस्ट रिस्पेक्टेड प्रोफेसर असित के चक्रवर्ती सर हमारे साथ जुड़ चुके हैं। गुड मॉर्निंग सर। आज के हमारे कीनोट स्पीकर रेस्पेक्टेड प्रोफेसर आर के शर्मा सर हमारे साथ जुड़ चुके हैं। आज के हमारे चीफ गेस्ट रेस्पेक्टेड जीडी यादव सर हमारे साथ जुड़ चुके हैं। मॉर्निंग सर। आप सबसे रिक्वेस्ट है कि प्लीज अपने स्पीकर्स म्यूट कर लीजिए एंड डोंट शेयर स्क्रीन। हमारे गेस्ट ऑफ ऑनर सब्जेक्ट स्पेशलिस्ट सर रिस्पेक्टेड डॉक्टर ब्रिजेश यादव सर हमारे साथ जुड़ चुके हैं। गुड मॉर्निंग सर। A very good morning to all of you. I, Supriya Agrawal, Gangashil Mahavidyalaya, Nawabganj, Bareilly, warmly welcome you all in today's international webinar on the role of green chemistry in controlling environmental and ocean pollution, which is conducted by the Chemistry Department of Gangashil Mahavidyalaya. This webinar is the last 14th link of the series organized by a college to make the proper utilization of time during COVID-19. But before that, we pray to Goddess of Education, Goddess Saraswati, as our culture inspires us to pray the God before starting any work. So, for successful webinar, we pray to Goddess Saraswati. I request to Dr. Tarun Pandey sir to play Saraswati Vandana.
शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या कुन्देन्दु तुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्कर प्रभृतिभिर्देवैः सदा
थैंक यू सर। अब मैं हमारे महाविद्यालय की प्रबंध निदेशिका मैम, रिस्पेक्टेड डॉक्टर शशिवाला राठी मैम, जिनके आशीर्वाद से आज हम ये वेबिनार आयोजित करने में सफल हुए हैं, जो हमेशा हम सबको प्रेरित करती हैं, को आमंत्रित करते हुए स्वागत करती हूँ, रिस्पेक्टेड डॉक्टर शशिवाला राठी मैम।
थैंक यू सुप्रिया जी। थैंक यू सुप्रिया जी। यहाँ उपस्थित इस एक दिवसीय वेबिनार में मैं सभी वैज्ञानिक मानस को नमन करती हूँ। आवश्यक होगा कि हम जो सरस्वती वंदना अभी यहाँ प्रस्तुत हुई है, मैं उनको भी नमन करूं जिनकी आवाज हमें अत्यंत रोमांचित कर गई है और एकदम से श्रद्धा भाव उत्पन्न कर रही है। देश की मानी जानी हस्ती गायिका लता मंगेशकर जी को मैं नमन करती हूँ और आज के इस वैज्ञानिक मंच पर उपस्थित देश विदेश के जाने माने ख्याति प्राप्त वैज्ञानिकों को मैं भाव के साथ नमन करती हूँ। हमारे बीच आज के इस वेबिनार के मुख्य अतिथि प्रोफेसर गणपति डी यादव साहब, जो 2020 में पद्मश्री से सुशोभित किए गए, अलंकृत किए गए। आपका अकादमिक करियर बहुत विशाल है, लंबा है। आपने मानव जाति के लिए, विश्व के कल्याण के लिए ग्रीन केमिस्ट्री पर बहुत काम किया है सर। मैं आपको बड़ी शिद्दत के साथ नमन करती हूँ। गंगाशील महाविद्यालय की ओर से आपका स्वागत और अभिनंदन करती हूँ। आप पूर्व कुलपति इंस्टीट्यूट ऑफ केमिकल टेक्नोलॉजी मुंबई से रहे और देश विदेश के अन्य अनेक विश्वविद्यालयों में प्रोफेसर के पद पर आज भी कार्यरत हैं। आपके जगह जगह एमिनेंट एक स्कॉलर के रूप में, प्रोफेसर के रूप में आपके लेक्चर होते रहते हैं। आप कई देशों में अध्ययन अध्यापन में जुड़े हुए हैं। एक खास बात यहाँ जरूर करना चाहूंगी कि आपके आईसीटी के नेतृत्व में आपने 23 नए अकादमिक प्रोग्राम शुरू कराए और 5 नए विभाग स्थापित हुए। कई सेंटर ऑफ एक्सीलेंसी आप वहां प्राप्त हुई आपके नेतृत्व में। 2 नए सेंटर कैंपस भुवनेश्वर में और मराठवाड़ा में खोले गए, स्थापित किए गए। आपके निर्देशन में आईसीटी ने टाइम्स हायर एजुकेशन रैंकिंग में प्रथम 100 में स्थान प्राप्त किया। आपके 125 राष्ट्रीय और अंतरराष्ट्रीय आपको नामी ग्रामी अवार्ड से समय समय पर नवाजा गया है और देश विदेश से फेलोशिप के लिए आप चयनित हुए हैं। आपके अंडर में, आपके निर्देशन में 100 पीएचडी प्राप्त 100 शोधार्थियों ने पीएचडी की डिग्री प्राप्त की है और 115 मास्टर थीसिस आपके अंडर में हुई है। आपके और बहुत सारे कार्य जो बाद में सुप्रिया जी यहाँ प्रस्तुत करेगी, बहुत लंबा अकादमिक अनुभव और ऐसे वैज्ञानिक को अपने बीच पाकर मैं बहुत हर्ष का अनुभव कर रही हूँ। सर नमस्कार सर। आपके आज के उपस्थित इन वैज्ञानिकों की श्रृंखला में हमारे बीज वक्ता के रूप में डॉक्टर आर के शर्मा साहब उपस्थित हैं। आप कोऑर्डिनेटर हैं ग्रीन केमिस्ट्री डिपार्टमेंट ऑफ दिल्ली यूनिवर्सिटी में। आपके अंडर में 36 थीसिस लोगों ने पीएचडी डिग्री प्राप्त की है और 8 लोग अभी आपके अंडर में काम कर रहे हैं। 15 लोगों ने एमफिल डिग्री प्राप्त की है। आपकी 16 बुक्स और उनमें मोनोग्राफ्स प्रकाशित हुए हैं। आपके 150 से अधिक उच्च श्रेणी के शोध पत्र भारत और भारत से बाहर के देशों में प्रकाशित हो चुके हैं। आप बहुत सारी संस्थाओं के मेंबर हैं। इनमें कॉन्फ्रेंस आपने ऑर्गेनाइज की है और प्रेजेंट भी किए हैं, उसमें आपने वो 30 हैं। आपने बहुत सारे लेक्चर डिलीवर किए हैं। रिसर्च प्रोजेक्ट आपके 19 हैं और आपको बहुत सारे पुरस्कारों से विभूतियों से नवाजा गया है। ऐसे वैज्ञानिक को मैं नमन करती हूँ और महाविद्यालय में आपका स्वागत और अभिनंदन करती हूँ। हमारे बीच एक और वैज्ञानिक डॉक्टर A.K. चतुर्वेदी साहब उपस्थित हैं, जो विजिटिंग प्रोफेसर हैं डिपार्टमेंट ऑफ केमिस्ट्री IIT रोपर पंजाब में। आपकी 168 से अधिक रिसर्च पेपर और आर्टिकल्स प्रकाशित हैं। आपने 4 रिव्यू किए हैं। आपकी 2 किताबें और प्रकाशित हैं। आपने 42 आपके जो लेक्चर हैं वो डिलीवर्ड हुए हैं और पेटेंट है आपके 42 और आपके जो वर्क है, फील्ड वर्क है, वो बहुत लंबा चौड़ा आपने फील्ड वर्क किया है। ऐसे वैज्ञानिक को अपने बीच पाकर मैं बहुत ही शिद्दत के साथ आपको नमन करती हूँ। महाविद्यालय की ओर से आपका स्वागत और अभिनंदन करती हूँ। हमारे बीच यहाँ उपस्थित वैज्ञानिकों की कड़ी में डॉक्टर S.K. शर्मा साहब हमारे बीच उपस्थित हैं, जो एसोसिएट प्रोफेसर रहे बरेली कॉलेज बरेली में। आप HOD वहाँ रहे डिपार्टमेंट ऑफ केमिस्ट्री बरेली कॉलेज बरेली में। एक्स मेंबर आप RDC के रहे। आप EC के भी मेंबर MJP रोहिलखंड विश्वविद्यालय में EC के मेंबर भी रहे हैं। लाइफ मेंबरशिप आपकी है ICC की और रिसर्च कोऑर्डिनेटर और केमिस्ट्री एंड बायो और इनऑर्गेनिक फील्ड में आपका विशेष कार्य है। आप देश विदेश में आपके बहुत सारे शोध पत्र प्रकाशित हो चुके हैं और आपका रिसर्च के फील्ड में भी एक बहुत बड़ा काम है। ऐसे वैज्ञानिक मानस को मेरा नमन और महाविद्यालय में आपका स्वागत और अभिनंदन। हमारे बीच एक और वैज्ञानिक जो कि मैसेडोनिया से हैं, वो उपस्थित हैं ब्रजेश सिंह यादव साहब, डॉक्टर ब्रजेश सिंह यादव। आपका रिसर्च पब्लिकेशन का एक लंबा आपको अनुभव है। आपके में 31 रिसर्च पेपर पब्लिश हैं। आपके बुक्स चैप्टर हैं बुक के अंदर, वो 3 हैं और आपके लेक्चर भी समय समय पर आप देते रहे हैं देश विदेशों में। वर्कशॉप आपने ऑर्गेनाइज किए हैं, ज्वाइन किए हैं, वो 7 हैं और पेटेंट आपके 8 हैं। आप विभिन्न सोसाइटीज के मेंबर रहे हैं, जिसमें यूरोपियन बायोकेमिस्ट्री बायोकेमिकल सोसाइटी, अमेरिकन सोसाइटी ऑफ प्लांट बायोलॉजी, इंटरनेशनल सोसाइटी ऑफ एप्लाइड लाइफ साइंस। इस तरह से आपका एक बहुत बड़ा अकादमिक व्यक्तित्व है। ऐसे महान व्यक्तित्व को अपने बीच पा मैं बहुत ही शिद्दत के साथ आपको नमन करती हूँ। महाविद्यालय में आपका स्वागत और अभिनंदन करती हूँ सर। हमारे बीच मेरे मेंटर डॉक्टर NL शर्मा साहब उपस्थित हैं, जो गंगाशील महाविद्यालय के महानिदेशक के पद पर आसीन हैं और आपके नेतृत्व में हम ये कार्य सब करने में सक्षम हो अपने को कर पाते हैं और मैं उनको भी इस वेबिनार में बड़े ही शिद्दत के साथ आपको नमन करती हूँ। महाविद्यालय, आपके ही महाविद्यालय में आपका स्वागत और अभिनंदन सर। हमारे बीच जो देश के, भारत के 23 स्टेट से यहाँ पर प्रतिभागी लोग उपस्थित हैं, वैज्ञानिक उपस्थित हैं, जो आज के हमारे इस जो गैलेक्सी में हमारे वैज्ञानिक उपस्थित हैं, उनको सब सुनेंगे और उनसे एक निश्चित तौर से रास्ता प्राप्त करेंगे। आज की इस ये वेबिनार का जो टॉपिक है, द रोल ऑफ द ग्रीन केमिस्ट्री इन कंट्रोलिंग एनवायरमेंटल एंड ओशन पॉल्यूशन, बहुत बड़ी समस्या देश की, जिस पर आज यहाँ पर विचार मंथन होगा, विश्लेषण होगा और हम किसी संश्लेषण पर पहुंचेंगे, किसी दिशा को प्राप्त करेंगे। एक बहुत बड़ी समस्या आज विश्व के सामने है कि तमाम पॉल्यूशन हम देख पाते हैं, इनमें हम अगर पाए, बात कहना चाहूंगी कि यद्यपि बहुत सारे नियम और रास्ते बनाए गए हैं, लेकिन सबसे बड़ी बात एक है उनके क्रियान्वयन की समस्या। मेडिकल वेस्ट, घर से निकला हुआ कूड़ा, पॉलीथीन की रिसाइकलिंग, खाद्य पदार्थ जो मार्केट में हमें दिखाई देता है कि सब्जियों के ऊपर भी कलर है। इसके अलावा इंसेक्टिसाइड और पेस्टिसाइड जो खेतों में लगाए जाते हैं, जिससे पृथ्वी की उर्वरता तो कम होती ही है, लेकिन निश्चित तौर से उन खाद्य पदार्थों का सेवन कर हम सभी मानव और जीव जंतु इससे निश्चित तौर से प्रभावित होते हैं। इसके अलावा हवा में जाने वाली गैसेस जो बहुत ही हानिकारक हैं, और इसके अलावा जो फैक्ट्री है उससे निकला हुआ रासायनिक जो द्रव है, वेस्ट मटेरियल है, वो पानी में ऐसे ही नालियों के द्वारा नदियों में डाल दिया जाता है और नदियां वो समुद्र में मिल जाती हैं। तो समुद्र की वनस्पति और उसके जीव जंतुओं पर कितना उसका घातक प्रभाव हो रहा है, ये चीजें। और एक चीज मैं यहाँ और कहना चाहूंगी, निश्चित तौर से सभी पर दिशा में काम हो रहा है कि एक हार्मोन्स आज हमारी वनस्पति में बहुत इस्तेमाल हो रहा है। इसमें कोरोजन और एक फटीराज इसको बोलते हैं। इसमें जो रिकमेंडेड है जितना खेत के अंदर डालना चाहिए वो भी डाला जाता है। किसान और हमारी मानव प्रकृति जो अधिक से अधिक लाभ के लिए चल पड़ी है, हमारी प्रवृत्ति के कारण ये किसान इसको बहुत ज्यादा इस्तेमाल करता है कि जल्द से जल्द हमारी जो सब्जियां हैं और हमारे खाद्यान्न है उनका साइज बहुत बड़ा हो जाए और उसे अधिक धन की प्राप्ति हो सके। ज्यादा उपज के लिए इन हार्मोन्स का इस्तेमाल कहाँ तक ठीक है, ये एक मेरे जहन में कुछ थोड़े से सवाल उठे हैं। निश्चित तौर से मंच पर काफी इनका मंथन होगा, चिंतन होगा आज की इस विकट समस्या का। मैं पुनः एक बार यहाँ पर उपस्थित सभी वैज्ञानिकों को नमस्कार करती हूँ, उनका स्वागत और अभिनंदन करती हूँ। नमस्कार।
थैंक यू मैम। अब मैं इस वेबिनार के कार्यक्रम सचिव रिस्पेक्टेड पंकज सर को इनवाइट करती हूँ कि वे आए और आज के वेबिनार के सब्जेक्ट इंट्रोडक्शन के बारे में हमें बताएं। पंकज सर।
थैंक यू सुप्रिया मैम। यहाँ उपस्थित सभी विद्वान वक्ताओं का, हमारे अतिथिगण, इन सभी का बहुत बहुत अभिनंदन और मैं स्वागत करता हूँ। आज का टॉपिक जो वेबिनार का है हमारा, वो द रोल ऑफ ग्रीन केमिस्ट्री इन कंट्रोलिंग एनवायरमेंटल एंड ओशन पॉल्यूशन। जैसा कि हम आजकल देख रहे हैं, कोई भी प्रोडक्ट हम बनाते हैं उसके साथ साथ हमारे बाय प्रोडक्ट्स भी हर केमिकल रिएक्शन में उत्पन्न होते हैं, जो किसी न किसी तौर पर हमारे एनवायरनमेंट को पॉल्यूट करते हैं। यानी कि जो पॉल्यूशन जो होता है हमारा, मेनली हमारे वेस्ट के प्रोड्यूस होने से होता है। तो आजकल जितनी भी हमारी केमिकल रिएक्शन हैं, कोई भी हम प्रोडक्ट बना रहे हैं, तो हमारा मोटिव ये होना चाहिए कि हमारे जो प्रोडक्ट का वेस्ट है वो कम से कम हो। तो कैसा हम ये क्या करें, कैसे ये करें जिससे कि हमारे प्रोडक्ट का वेस्ट कम से कम बने, क्योंकि पॉल्यूशन जो होता है मेनली वेस्ट के कारण होता है। अगर वेस्ट नहीं बनेगा तो पॉल्यूशन भी कम से कम ही होगा। इसमें हमारी ग्रीन केमिस्ट्री काफ़ी रोल प्ले कर सकती है, क्योंकि काफ़ी सारे रिएक्शन ऐसे हैं जो हम करते हैं और उसमें हमारा बाय प्रोडक्ट बनता है। बट कुछ मेथड ऐसे ग्रीन केमिस्ट्री में यूज हो रहे हैं जिनका हमारे आज के विषय विशेषज्ञ बताएंगे कि कैसे हम प्रोडक्ट वेस्ट को इसको कम करें, क्योंकि फैक्ट्री से निकलने वाला वेस्ट अगर हम ट्रीटमेंट करते हैं उसका तो डिस्चार्ज करेंगे तो पॉल्यूशन रिवर्स बॉडीज वाटर पॉल्यूशन बहुत कम से कम होगा। बट उसका ट्रीटमेंट जो है बहुत ही कॉस्टली पड़ता है। लोग बिना फैक्ट्री विदाउट डिस्चार्ज के भी इसको वाटर बॉडीज में छोड़ देते हैं, जिससे वहाँ की लिविंग बायोलॉजिकल लाइफ डिस्टर्ब होती है। तो कहने का मतलब ये है कि हम अगर हमारा वेस्ट ही नहीं बनेगा, ऐसे रिएक्शन का यूज़ करें कि हमारे वेस्ट ही ना हो, जिसके कारण से हमारा पॉल्यूशन भी कम से कम ही होगा। तो इसी विषय पे आज हमारी चर्चा होगी कि किस तरह से हमारे वेस्ट कम हो, कैसे हो सकता है, इसी में हमारी ग्रीन केमिस्ट्री कैसे हेल्प कर सकती है। इसमें आज के हमारे सब्जेक्ट एक्सपर्ट और साइंटिस्ट इसके बारे में हमें आज बताएंगे। थैंक यू सुप्रिया मैम।
Thank you, sir. Now, I would like to invite the keynote speaker of today's international webinar. You are the coordinator of Green Chemistry Network Center, Department of Chemistry, Delhi University. You have more than 25 years of teaching experience. आप करंट रिसर्च इन ग्रीन एंड सस्टेनेबल केमिस्ट्री जर्नल के गेस्ट एडिटर और एडिटोरियल बोर्ड के मेंबर हैं। You acted as a member of various committees of the department as Bill Committee, Purchase Committee. Your article in 2018 is published in Top 100 Scientific Reports Chemistry paper. You have 4 patents, 21 doctoral theses are awarded under your supervision, and 8 doctoral theses are under progress, and 15 MPhil dissertations are guided under your supervision also. You have 16 books, monographs, and 150 research papers published. आपने लगभग 30 कॉन्फ्रेंसेज में प्रेजेंटेशंस दिए हैं। आपने कई रिसर्च प्रोजेक्ट्स पर वर्क भी किया है। You have received many awards also, as in 2017, you are nominated by DST to act as a member of expert committee to review ongoing or completed projects supported under Water Technology Initiative. You are the member of American Chemical Society, member of Royal Society of Chemistry, London. You are the life member of Indian Chemical Society, Calcutta, and member of DRC, Department of Chemistry, Delhi University. We welcome you, sir. Respected Professor R.K. Sharma, sir.
Thank you, Dr. Supriya. And first of all, are you able to hear my voice?
Yes, sir, exactly.
So, first of all, I would like to thank Mr. Pankaj for inviting me. और मैं देख सकता हूँ यहाँ प्रोफेसर चक्रवर्ती हैं, उनको नमस्कार, और प्रोफेसर आरबी सिंह हैं, उनको भी नमस्कार. As you can see, I am from Department of Chemistry, University of Delhi. मैं पहले आपको एक प्रेजेंटेशन भी करना चाहता हूँ. Presentation. Can you enable the presentation from there?
Yes, sir, we are trying. आपको sir, you have to share your screen with your presentation.
Yeah, that's what I'm doing from here. Because this is present now, entire screen.
Yes,
But
sir.
in the screen, yes. Are you able to? Today I'm going to talk about green chemistry. It is designing chemistry for human health and environment. As you can see, I'm from Department of Chemistry, University of Delhi. And recently, a Green Chemistry Network Center established in our university under the recommendation of a panel of world leaders headed by Professor Paul Anastas. This man is known as father of green chemistry. And this Green Chemistry Network Center is working for networking of different centers, green chemistry networking, and preparing and disseminating the green chemistry educational material, designing training workshops, and taking up green chemistry research projects. We had research projects from CSIR, UGC, DST, DBT, industry, and recently we got a major project from Ministry of Textile for setting up of GCNC laboratory. So, in my talk today, briefly, I'm going to share with you about our activity. But before coming to green chemistry, let us see what chemistry is giving us. You know, this is the chemistry which is not only extending the length of the life from 47 years to 75 years, but also increasing quality of life by providing so many things. So we chemists are making world worth living. But there is another side of chemistry. Chemistry also leads to toxic world. Chemistry also leads to waste disposal, pollution, danger, toxics, landfill, cancer. And according to the survey done by this Nobel laureate, humanity's top problems for the next 50 years are energy, water, environment, food, but the more serious problem is population growth. And our country like India, is facing serious problem because of the population growth. You see, 7 billion people in 2011 and expected to be 9 plus billion people by 2050. So what is happening because of this population growth? This is very interesting comparison of world population with the Indian population. You can see the whole UK population is equal to Rajasthan's population. Even whole Brazil's population is equal to UP population. So the population problem is very serious in our country. And because of that, what is happening, you just see the nature provides us the resources and we are consuming resources and creating waste. And again, nature converts this waste to the resources, and that way the cycle goes on. But what we are doing, we are exceeding the carrying capacity of the earth. We are using resources and creating waste faster than the earth can take our waste and convert them back into the resources. So now this is one way, resources to waste. So question arises, can green chemistry can help in this regard? We'll discuss about that also. But before that, I just want all of you to recognize this picture. This looks like a graphic art, but this is not. Take a more closer look. A more closer look. You know, 2 million plastic bottles discarded every 5 seconds in the US, and 86% of plastic bottles used in US end up in landfills, taking up 1,000 years to biodegrade. And you see, only generation, there is no recovery at all. So this is a very serious problem. Even this plastic contamination in oceans. See, the 90% floating debris in oceans is plastic and projected to grow tenfold in 10 years. And plastic found in 48 to 86% seawards and marine mammals. More serious problem associated with this is these plastic bottles which we are using for drinking water containing a harmful chemical bisphenol A. And these plastic bottles releases this harmful chemical after contact with hot liquid. And recent research says that this BPA, bisphenol A, linked to the breast cancer in women, brain damage in children, obesity, heart disease, etc. And even then, we are using these plastic bottles. Another picture which, if you can recognize this, This also looks like graphic card, but this is not. Take a more closer look. A more closer look. You see, 4,26,000 cell phones retired each day in US. And India is the second largest mobile phone market in the world after China. So this e-waste is very dangerous. And what US is doing in terms of recycling of this e-waste, between 50 to 80% of the e-waste collected for recycling in US are not recycled, but is very quickly placed on containers, ships bound for destination like China or India. And this is not the solution. And according to the US Department of Toxic Substances Control, the most electronic devices are toxic based on 1,000 different substances in e-waste. See, lead, tin, copper, antimony, all of these are poisonous to people and wildlife. And so this e-waste is very dangerous. According to this report in Times of India, Delhi is the second largest producer of e-waste in the country after Mumbai. 3, 4 times Doordarshan invited me to discuss about this problem of plastic waste and e-waste in live show, and we have discussed about this and the role of green chemistry in this. Now, the big question before us is within the next 50 years, how can we provide 8 to 10 billion people with energy, water, food, quality of life, and future technology? And that is without global warming, without resource depletion, and without toxics in the environment. And one of the answers from my side is green chemistry. So I'm going to elaborate this also in my talk. But before that, the question comes in our mind is what is this green chemistry and why we are talking now about green chemistry. So I'm going to define this first, that what is this green chemistry, just by taking one slide and one relation. You know, risk is a function of hazard and exposure. If you want to minimize risk, either you minimize hazard or you minimize exposure. And the traditional way of minimizing risks is by minimizing exposure, putting gloves, safety glasses, helmet, lab coat. This is a traditional way. But if we can minimize this hazard, reduce or eliminate this hazard, we can minimize the risk, even if there is any accidental exposure. And this is the approach for green chemistry. Green chemistry is defined as the design of chemical products and processes that reduce or eliminate the use and or generation of a other substance. This is green chemistry. And slowly, people started recognizing the benefit of green chemistry. And in 2005, the Nobel Prize went to green chemistry. And see the comments of the Nobel Committee. They said this is a great step forward for green chemistry, applying basic science to the problems of man, society, and the environment. So this proves that best chemists in the world are doing green chemistry. This is a book written by founders of green chemistry. There are two founders of green chemistry, Paul Anastas and John Gardner. They had written a book which is very good for the beginners, green chemistry theory and practice. And in this book, they had written 12 principles of green chemistry. And these 12 principles, this book is already translated into several languages. And these 12 principles, actually, the 12 tenets of green chemistry. So these 12 principles that provide a framework for design of new material, products, and processes. And systematic integration of these principles is key to achieving genuine sustainability for the simultaneous benefit of the environment, economy, and society. These are the 12 principles of green chemistry, but I'm not going to touch these 12 principles. I'm not going to explain this because explaining these 12 principles will need at least one semester. Now, the biggest challenge of green chemistry is to get people to adopt it, to convince people to do green chemistry. Green chemistry is good to convince them. So we started this mission from 1999 onwards. National Symposium was organized by us. Then in 2001, IUPAC International Symposium on Green Chemistry was organized. You can see this was inaugurated by that time the Chief Minister Sheila Dikshit. James Clark, famous man of green chemistry in UK, he came. Professor Tundo from Italy, he came. Even ACS Green Chemistry Institute director came and participated. Terry Collins, famous for the work on catalysts, he came and participated. Though this proves to be good conference, international conference, but we found that the people were reluctant to change. They don't want to change. They were taking very lightly about the green chemistry. They were saying that if there's green chemistry, there should be yellow chemistry, pink chemistry, red chemistry. But we knew about the benefit about this green chemistry, and we knew that the change always comes much more slowly than anyone would expect. And simply stated, people don't like to do things differently from the way they have done them before. They don't want to come out of their comfort zone, and new ideas and new perspectives often face harsh opposition. There are few interesting examples to support this. You know, the Mendeleev, the inventor of periodic table, refused to acknowledge the existence of radiation or even the electron. Einstein, great Einstein, rejected quantum mechanics. He said, quantum theory is certainly imposing, but an inner voice tells me that it is not yet the real thing. Even the last very interesting example is of this Nobel Prize winner. He won the Nobel Prize in 2011 for discovering the existence of this type of crystals, quasi crystals. He said when he discovered these, people just laughed at me. Even head of his research group, uh, after telling Daniel to go back and read a crystallography textbook, the head of his research group asked him to leave for bringing disgrace on the team, and I felt rejected. So this happens, and we continued working for the popularization of green chemistry, and these words of Mahatma Gandhi encouraged us. Mahatma Gandhi said, first they ignore you, then they laugh at you, then they fight you, and then you win. So we continued for the mission popularization of green chemistry in India. And we knew that if we want to incorporate green chemistry principles in academia or industry, the best way is by organizing workshops, not the conferences. So the first workshop we had organized by the support of Indo-US Science and Technology Forum. And in that workshop, you can see the DSC secretary at that time, this man, he came to inaugurate the inaugural session or to inaugurate the workshop. And this man delivered the inaugural lecture. And this man is Paul Anastas, father of green chemistry. So that time he was a scientific advisor to US President. So he came from Washington and delivered inaugural lecture. All the world leaders, they participated in this workshop. You can see that Terry Collins, famous for catalysis work, even got the presidential award for the catalyst designing. This Dr. Mary Kirchhoff, she's now director, American Chemical Society's Green Chemistry Institute. Robin Roger, famous for ionic liquid work, got the presidential award also for this work, ionic liquid work. John Warner and Paul Anastas, these two are the founders of green chemistry. So they all participated in this workshop and recommended that if green chemistry is to grow in India, then there should be a green chemistry networking. So we started working on a networking mission. So we started this. We got continuously for 3 years IUPAC Cameron GCI then grant award for this networking activity. A simple form is there anyone who is interested in green chemistry and wants to help us in popularization of green chemistry can fill up this form. There is no fee and can become a member of Green Chemistry Network. We are going to schools also. You can see all the Delhi and Gurgaon schools, they organized a symposium on green chemistry. Sorry. And I have delivered the keynote address in that symposium. Every year we are organizing workshops, training workshops, for green chemistry students, educators, and industries. You can see 2009, 10, 11. This is in 2015, and this valedictory session, or these are the participants of that workshop, and valedictory lecture was delivered by Dr. Ashutosh Sharma. Presently, he is Secretary, DST. We are not only in Delhi, we are touching all parts of the country. So we are conducting and participating in green chemistry workshops and conferences that were held in many parts of the country. You can see Nagpur, Assam, Punjab, Hyderabad, Gujarat, then Sikkim, Rajasthan, Gujarat, Punjab, Mizoram, Uttar Pradesh, Kanpur, then Central University, Garhwal, Himachal Pradesh, Bihar, Himachal Pradesh, Punjab, Rajasthan, Kerala, Udaipur, Jaipur, Jaipur again international workshop. This was in Jalandhar. This is Punjab University, Chandigarh. Now the question arises that we are going to different parts of the country delivering popularization lecture. What is the result of all? Is there any benefit, any result? So I'm just going to share one result out of these activities. Wealth came from green chemistry. Share with you this real world case. You know, the green chemistry is about reducing waste, reducing material, reducing hazard, reducing risk, reducing energy, reducing environmental impact, and reducing cost. And this is all followed in this real world case. So I want to share with you this real world case. What was that case? You know, the ranitidine HCl is an important and cheapest anti-ulcer drug kept available to common men. And SMS Pharmaceutical, though these are the producers of this drug, but SMS Pharmaceutical Hyderabad was the world's largest manufacturer of this drug. So what happened? The Central Pollution Control Board and the State Pollution Control Board asked these two companies, SMS Pharmaceutical and Saraka, asked them that shut the production, stop production due to the methyl mercaptan gas emission as waste from manufacturing process. So because of the emission of this toxic gas, they were instructed by the Andhra Pradesh Pollution Control Board to shut the plant, to shut the factory and stop production. This was the traditional method of production. You can see this is raw material, DMSO raw material, and production of ranitidine followed by methyl mercaptan, which is a toxic gas. Methyl mercaptan is very toxic gas and very horrendous smelling gas. Even you can smell this gas even at a level of 1.6 ppm. This is having the order of rotten cabbage. These are, you can see the toxic effect. So here, even the traditional methods were ineffective. You can see so much input and the output is solid waste, unwanted gas, and even then there is a release of methyl mercaptan. So now the green chemistry came into the play. A green chemist who is working with us for the popularization of green chemistry, Professor Mihir K. Chaudhary. He designed a catalyst for this industry. That time he was the professor at IIT Guwahati. Now, after that, he became vice chancellor at Tezpur Central University for the 2 terms, and now he is advisor higher education, Assam government. So he designed catalyst for this industry, and that catalyst converted this methyl mercaptan, which was the toxic gas, to DMSO. And DMSO was a raw material they were using. So what was the toxic waste that was converted to raw material, and they used this DMSO for the production of ranitidine. So that way the cost came down 40% reduction in cost because of this catalyst. So Advantage, advantages were the low capital cost, reduced cost of production, nominal supervision, highly protective, and environmental friendly. I got a letter, invitation letter from this industry, and in that letter, they invited me and they had written that being inspired by your speech in the conference on green chemistry held at IIT Guwahati, we have concentrated on one of the burning problem of Hyderabad industry. So the same way as I am delivering here the popularization lecture, I was delivering the lecture in a conference at IIT Guwahati. Industry people did have to board, Adishma and Mr. MDN Sema, member secretary, Karnataka State Pollution Control Board. So these two were there. Everything was clean, no smell. They have explained everything. We have seen the real working of the plant. There was no smell, and these pollution control board people were so happy that they said, if you are organizing another workshop on green chemistry, please invite us also. And we have given this case on our website as a real world example. So after that, we got a mail from Dr. Reddy's lab. You know the Dr. Reddy's lab, a major pharma industry. We got a mail from them that ours is a pharmaceutical industry manufacturing ranitidine. As per the website, there is development on wealth from waste. Say methyl mercaptan gas is converted to DMSO. Can I know more details on this? Uh, so we have guided Dr. Reddy's lab also, and they are also putting a plant at Hyderabad. These are the 12 principles of green chemistry, and one of the very important principle is use of selective catalyst. And according to this Nobel laureate, Nobel Prize winner, catalyst is the engine that drives the development of chemistry. And the catalysts are essential in the synthesis of 80% of chemical industry products. And one of the great things about the catalysts is that even a single improvement in their performance can be worth millions. So this is a very important area. And to support this, you can see the Nobel Prize winners working on the catalysis area. 2005, 2001, 73, 63, 1918, 1909, 2010 Nobel Prize in Chemistry awarded for palladium catalyzed organic synthesis. So we are also, my group is also working on catalysis area. There are two types of catalyst, homogeneous and heterogeneous. Homogeneous catalysts are active and selective, but heterogeneous catalysts are not so active and selective, but they're easy to separate and reuse. So what we are doing, we are combining the activity and selectivity of the homogeneous catalyst with the ease of separation and reuse of homogeneous catalysts. We have reviewed our work in a review that is published in a Green Chemistry Journal as well as in Coordination Chemistry Reviews. In last few years, publications from our research group. You can see inorganic chemistry, ChemSusChem, then ChemCatChem, RSC Advances, Material Chemistry Frontiers, ACS Omega, Material Horizons, Chemical Education, ChemCom, SCS Omega, ChemSelect, SCS Omega, um, Industrial and Engineering Chemistry Research, ACS, Nature Scientific Report, then Green Chemistry Select, Green Chemistry, CS Omega, Green Chemistry, Chem Plus Chem, ACS Sustainable Chemistry and Engineering, Journal of Material Science, ChemCat Chem, New Journal of Chemistry, Green Chemistry, Catalysis Science and Technology, Dalton Transaction, Journal of Material Chemistry, Green Chemistry, Dalton Transaction, mm, Applied Catalysis A, then Catalysis Communication, Electrical Methods, Inorganic Chemical, Applied Catalysis B, uh, then hazardous material, Journal of Hazardous Material, Green Chemistry, Polyhedron, Catalysis. And I'm very happy to share with you that we got a mail from the editor of Green Chemistry, and this mail says that I'm emailing to let you know that your article was one of the most downloaded article in Green Chemistry. So I'm very happy that our work was recognized worldwide. Not only this, our one paper, which was on an efficient copper waste magnetic nanocatalyst in the fixation of carbon dioxide at atmospheric pressure, was selected as top 100 scientific report chemistry papers in 2018. So I'm happy that at least we are doing some work on green chemistry. So considering the utility of our work, we have written a book. World Scientific Publishers, they invited me, and we have written a book on that work, compiled that in the form of a book, and that was published by World Scientific. Wherever we are going, or I'm going for delivering lecture, I'm just showing industry and academia the impact factor of the journals. You see the pure chemistry journals, Dalton, Inorganic, or they are having impact factor 2, 3, 4, like this. But the green chemistry journals or journals dealing with the environment are having high impact factor, like green chemistry 9.4, even the applied catalysis B environment having around 16 impact factor. We're going to industries also. This is a workshop we have organized for industries, Mumbai. And in this workshop, around 300 chemical industries participated, 65% of the chemical companies. And in this workshop, that time, DST Secretary Ramaswamy, he came, Paul Anastas came, John Warner, you can see the founders of Green Chemistry. I'm going to industries also. They are inviting me, and I'm going there to deliver here. This is the conference organized by Gujarat Industries and Pollution Control Board, and I was opening a speaker, and this came in the newspaper also. Even our Prime Minister Modi praised about this. Uh, if you know about Dr. Reddy's lab, every year they are organizing Science Day Symposium, API Science Day Symposium on Science Day. So last year on 11th July Science Day Symposium, in this symposium they invite one scientist, professor or industrialist from outside the industry to deliver the lecture. So this time I was invited by them to deliver the lecture on green chemistry. So you can see this. Even I was invited by the JICE Japan in 2019 January to deliver the lecture on green chemistry. This is the world's second largest analytical chemistry symposium every year organized at Princeton, New Jersey. This was organized in November 2019, and they have included green chemistry also with sustainable solution, and I was also invited as a speaker, and I delivered the lecture on green chemistry and water treatment from vision to action. This is another real world case where we were involved. You can see this is the periodic table, and these elements, these metals, red colored, are exhausting. They are only for 5 to 50 years because recklessly we are using these metals and throwing these metals into the environment. And that's why these reserves are exhausting. Even you can see the supply of metals running out, and because of that there's resource benefit, and because of that you see the prices. Since 2000 the price of copper has quadrupled. The rare earth elements have collectively increased in price by a factor of 20. Indium price rose a staggering 800% in 6 years, and this is the case for all bulk metals, precious metals, and rare earths. Even there's a recent report in Hindustan Times that because China is having rare earth reserves, rare earth metals reserves, so will China weaponize rare earth metals and trade war with US? Even US is funding around. He is investing millions of dollars to extract these rare earth metals from coal waste, giving the projects. This is just see this is came in chemical and engineering news also, rare earth recovery. So there is depletion of resources at an alarming rate, and recapture of these metals are highly desirable. We have developed a special type of chelating polymer where on the inorganic polymer support we have immobilized a chelating agent selective to a particular metal ion, and that worked very good for extracting the metal. You see, this is the solution containing chromium, and we have when we have added this chelating resin, all the chromium was absorbed, and again we can reuse that. We can again elute that, and this scavenger, this you can see again chromium, and after addition of scavenger, and we have patented this also. This is the small bioreactor we have developed for online extraction of chromium. We can extract that, and we have patented that also. You know, the Kanpur is facing so much problem because of the chromium, because of the tannery industry. So I was invited by college, DAB college there, very old college, and the Kanpur University vice chancellor was there, and I delivered the keynote address in that college, and maybe around 10,000 participants were there, and this became so popular. All the media and television, they covered this news. Even we had organized this international workshop on sustainability and water quality, and in that workshop, because this was sponsored by the Global Innovation Imperative and ACS. So around six experts came from US. You can see those experts, and we have demonstrated our technology before them. And this came in times of India. DU teams claimed to have developed a solution for chromium pollution. Developed the chelating resins or chelating polymers for other metal ions also, like palladium, and this was for molybdenum, and this is published in Journal of Material Chemistry for lead. We are writing the chapters also in different. This is RSC Green Chemistry series, green material for sustainable water remediation and treatment. Um, these are all chapters. Even now we have developed a nano-adsorbent nanomaterial, magnetic nanomaterial, which can absorb the chromium from the solution, and we can separate that. So recently we got around 50 lakh project from DST to work on that, to develop a bioreactor. Just I will stop by showing you some educational material developed by us. So we have incorporated three papers on green chemistry in undergraduate syllabus of Delhi University. And some of the very good colleges, even top ranking colleges like Hindu or Miranda House, they are running add-on courses on green chemistry and we are helping them. Recently, we have introduced one paper as a general elective course paper on green chemistry, designing chemistry for human health and environment. And this can be opted by any branch student, any like you can from arts or any other subject. Mm, Central University Rajasthan is the first central university in India started MSc Green Chemistry, and we have developed the for syllabus for this university. You can see chemistry specialization in green chemistry. We have published a green chemistry experiment monograph, and in that the foreword was written by father of green chemistry, Professor Paul T. Anastas. And this was released by a cabinet minister and founder of green chemistry. Funding received from DST. Before starting any experiment, we are instructing the students, see what chemical you are dealing with can be a high risk chemical. So what you should do is first look at MSTS. And this material safety data sheet is freely available on website, this website. Anyone can see this from this website. The green chemistry is the major incentives are the safety, performance, and cost. So we have developed the green chemistry experiment, and we have considered the following criteria for judging the greenness: reduce lab-based waste, illustrate green chemical concepts, teaches modern reaction chemistry and techniques, can be accomplished during a typical lab period, use in expensive greener solvent and reagent. This is just one experiment I just want to show you or demonstrate here. This is just the extraction, green extraction solvent liquid CO2. We have extracted D-limonene from orange peel. So you see the organic solvent which are used for the extraction are very toxic, even highly volatile, fire hazard, costly. And the advantage of CO2 is this is non-toxic, non-inflammable, chemically benign. For the students, they know this is a gas, they know this is a solid, but how can it be used as a solvent? So we can demonstrate that by showing the phase diagram at different temperature and pressure, the different states. This is the phase diagram. Now, in this experiment, what you require is simply a polypropylene tube, a copper coiled wire, dry ice from any ice cream stall, and orange peel. So, what to do? A copper wire was taken and coiled at one end, and a piece of filter paper was fitted in between the coil, like this. Coiled copper wire was taken, and piece filter paper was fitted in between the coil. The polypropylene centrifuge tube tapering at one end was taken and the wire was fitted inside it. The polypropylene tube was taken and wire was fitted inside it. The orange peel was grated using a cheese grater and filled like that. See, the orange peel was grated, and this was topped with crushed dry ice and sealed with a plug seal cap. This is a plug seal cap, and the tube was then put inside the plastic cylinder containing water at temperature 30 to 50 degrees Celsius, like this. Now you see just the demonstration of that experiment. The tube is coming into the water. You can see the dry ice is melting, and liquid CO2 is circulating through the orange peel. Yeah, so we got the pure limonene by this It saves time, affordable, safe, effective, convenient. You can extract natural products also from coffee, fruits, flowers, spices. We have also actually, DSC invited me to write monograph on green chemistry experiments, UG and PG. We had prepared that. Uh, and this is available on DST site. This site, anyone can see this PDF file. There are other experiment designed by us like nanotechnology, but I am just skipping that. We are publishing these experiments which are designed by us in this journal. This is a very good journal for those who are interested in green chemistry experiment, Journal of Chemical Education. This is a journal published by American Chemical Society, and this is the world's premier chemical education journal. So we have published this one experiment, preparation of gold nanoparticle using tea in this journal, and even we got a mail from the editor of that journal that our uh, experiment, this experiment, was the most read experiment. The pharmaceutical industry is the largest waste producing industry, the large quantity waste generator. So we had written or edited a book jointly with Rakeshwar Bandichor. He is the head chemistry at Dr. Reddy's lab. So with him, we had edited a book on hazardous reagent substitution, and this is published by Royal Society of Chemistry under the Green Chemistry series. We have a very active student chapter, international student chapter at University of Delhi, and even in Nexus, very famous letter published by Indian Chemical Society. They have given our chapters activities or highlight of our chapter. You can see these are my students working with us, my group. Even we got a major grant from ACS to participate with the student in the ACS National Meeting, New Orleans. This is one of my student. Now she is assistant professor in a college, but that time she was the president of the ACS student chapter. Got the best poster award from Richard Blackburn in 21st ACS GCI conference. Recently, we got the award, the Green Chemistry Award for this ACS student chapter from American Chemical Society. Even we got a major grant from ACS around 5,000 US dollar to organize the workshop. This year in December last year, we got funding from Newton Fund from British Council, ACS, and jointly we had organized an Indo-UK workshop with University of York. So this was an international workshop on green chemistry for societal needs, healthcare, pollution, and circular economies. And there were around 25 participants from UK and around 30 were from India. These are the group photograph of all those. This is my last slide. Whenever we take a substance, we investigate a substance or we do the reaction with a substance, we always consider the physical properties of a material like this is state of matter, color, melting point, boiling point, solubility, conductivity. But that day when we will consider these two also with this toxicity, impact on environment, I will stop delivering the lecture, popularization lecture on green chemistry, because green chemistry itself will be green. Chemistry itself will be green. Thank you. Thank you very much for your kind attention.
Thank you, sir. Thank you for the wonderful presentations. I think it is very useful for the participants of our webinar. And if anybody has any questions, He or she can ask.
कहाँ पर है?
You can message us in chat box or you can ask your questions directly.
Yeah, please let me know if there is any question.
Good morning, sir.
Morning.
Hello, can you hear me? Yeah. Here I can
Yeah.
see. Here I can see in the chat box there are many students. They are asking when we can see the green
Yeah.
chemistry as a major part of our graduation, either the degree level.
You know, green chemistry, actually, one thing I want to clarify, green chemistry is not a different chemistry. This is the same chemistry, but that chemistry should be good for human health and environment. So that's what we are doing. We are designing monograph, we are delivering lecture, we are inspiring students. We have introduced 3 papers in undergraduate syllabi here. We want to inspire them that whatever we are showing them, see that this is the traditional experiment you are doing with the solvent. You can see you can do the same thing with water and without solvent. So we are just changing that thing so that the student will get inspired, and wherever he will go, he will, like, one paper is common for everyone, for every subject, so that he can have this idea that wherever he will go, he will think of sustainability, he will think of trade.
Sir, there is one also question.
Yeah, let me.
Someone is asking that is there any solution in green chemistry to control releasing of carbon dioxide from industries?
You see, the same thing was there. You just see the methyl mercaptan gas was released, and they got the catalyst to convert that mercaptan to a raw material. Same way, different groups are working on that. That how to convert CO2 to the useful material. If you just go to the internet, you search, just put in the Google, you will find different papers, different groups working on it.
Thank you, sir. Sir, one more question, please. Mr. Vishal is asking, is it possible to implement green chemistry in degree lab?
Yeah, because we have already introduced 3 papers in Delhi University's undergraduate syllabi. So in the lab, they are doing those experiments based on green chemistry. This is there, and even not only this, many universities, IITs, they have started doing this.
Thank you, sir. I think our participants are satisfied with the questions. Thank you
Thank
so
you.
much, sir. Thank you for valuable time to us.
Hello, ma'am. Our last
Hello, yeah.
question is there.
Just a minute.
Provisions are there for reduction of carbon dioxide in that treatment solvents.
Yeah, just please mute your speaker and sir will answer your question shortly. Sir, one more question from Somajit Rajak. What provisions are there for reduction of CO2 emission except ionic liquids treatment as solvent?
Except
Ionic liquids.
ionically, yeah. Ionic. But if you are just talking about the ionic liquid, there are the problems in ionic liquid. Do you know that about that?
Sir, can you please highlight?
Yeah, there are problems with the ionic liquid because if you want to do this in a bigger industry level, you cannot use ionic liquid. And ionic liquid, some of the ionic liquid are very toxic. So this is the problem with the ionic liquid.
So, sir, is
Yes.
there any alternative?
Alternative of what?
Liquids using ionic liquids.
Please, participants, don't share your screen.
Yeah. So using ionic liquid, because there are you will find the research is going on. You will find there are the ionic liquids are developing which are green. They're not containing the toxic materials. So you can see that also. The groups are working on that how to do that. And even mm, there is a liquid CO2, and there is another extraction they are the people are doing. I'm just uh, missing the name. Mm, there's a number of things they are doing. If you just go to the Google and put that, you will find the number of ways. Groups
Okay.
are
Thank you,
working on
sir.
reducing those things. Any other question?
Okay.
Anything?
Any other question? Just a minute, sir.
Because
Yeah, just last one. Among the solvents, what is the best solvent? What is the best green
the
solvent?
best thing is you do without solvent, and the best solvent is the water. And here, if you see, you are going to listen Professor Chakravarti's lecture. I think he has published a full research paper on green solvent. Even he categorized the solvents there. So this is the best question for Professor Chakravarti. He will explain you about that, the
Okay, sir.
green solvents.
Thank you, sir. Thank you so much for giving your valuable time to us.
Okay,
Now,
thank you. Thank you
I
for inviting
invite,
me.
yes, sir. Now, I would like to invite the chief guest of our today's international webinar, respected Professor Ganpati D. Yadav, sir. He is one of the topmost, highly prolific and accomplished engineering scientists in India. He received so many and rare awards as an academician, researcher, and innovator, as in green chemistry and engineering, catalysis, chemical engineering, energy engineering, biotechnology, nanotechnology, and development of green and clean technologies. For 10.5 years, he served as the founding Vice Chancellor and R.T. Modi Distinguished Professor and Tata Chemicals Darbari Seth Distinguished Professor of Leadership and Innovation at the Institute of Chemical Technology. Currently, he holds the titles of Emeritus Professor of Eminence and J.C. Bose National Fellow in ICT. He serves as the Adjunct Professor at University of Saskatchewan, Canada, RMIT University, Melbourne, Australia, and Adjunct Professor, University of Newcastle, Australia. He was conferred Padma Shri, the highest civilian honor, by the President of India in 2016 for his outstanding contributions to science and engineering. He has been recipient of two honorable doctorates, that is DSc and D Engineering. Under his dynamic leadership, ICT made phenomenal progress, having been declared as Category 1 institute, having started 23 new academic programs, 5 new departments, and several centers of excellence, and establishment of 2 off campuses in Bhubaneswar with total support of IOCL, and Marathwada with total support of Government of Maharashtra, and collected phenomenal funds. He has personally won over 125 national and international honors, awards, fellowships, editorships, and several lifetime achievement awards by prestigious industrial organizations. He is an elected fellow of Indian National Science Academy, Indian Academy of Sciences, National Academy of Sciences, India, Indian National Academy of Engineering, as well as the World Academy of Sciences, TRIST. He is a fellow of Royal Society of Chemistry, UK, Institution of Chemical Engineers, UK, Indian Institute of Chemical Engineers, Indian Chemical Society, and Indian Society for Technical Education, among others. His research productivity is phenomenal with supervision of 100 doctoral and 115 master's theses, which is the first record in ICT and for any engineering professor in India. Besides, he has supervised 37 postdoctoral fellows, several summer fellows, and research staff. He has published 446 original research papers, 115 national and PCT patents, in which 70 granted, 3 books, H index of 57, I-10 index of 265, 12,000 publications in journals, patents, books, and monographs. He is still actively involved in guiding doctoral students, patenting, publishing, cutting, and transferring technologies to industry. The American Chemical Society published a Festschrift special issue of Industrial and Engineering Chemical Research 2014 in his honor with 65 original research papers from scientists from all over the world. He is the founder president of ACS India International Chapter. He is the founding editor-in-chief of Catalysis in Green Chemistry and Engineering 2017. He has been a member or chaired several national and international committees of MHRD, DST, DBT, UGC, AICTE, CSIR, or other PSAs on green chemistry, the Planning Commission's Pan India and S&T Committee, and the Government of Maharashtra's Rajiv Gandhi S&T, Hyderabad, and NIST Trivandrum. He has served as a chairman, member of selection committees of directors of many CSIR labs. He serves as independent director on 4 renowned public limited companies, that is RT Industries Limited, Godrej Industries Limited, Meg Money Organics Limited, and Bhagadia Chemicals Limited. And private limited companies, that is Clean Science and Technology Private Limited. He is also a member of Apex Council of Indian Oil R&D Expert Advisory Committee, ONGC, Energy Center, OEC, Glaxon India Advisory Board on Process Safety, and the Governing Council DBT Indian Oil Energy Center, and member of the DBT Pan IIT Center for Bioenergy. He is chairman of DST's National Expert Advisory Committee on Innovation, Incubation, and Technology Enterprise, member of Advisory and Screening Committee of the Common Research and Development Hubs of DSIR, chairman, PAC of International Programs in Chemical Sciences and Engineering, DST chairman, Expert Committee, Waste Management Technology, DST. He had the honor of addressing 3 convocations of renowned universities. He is fond of literature, etymology, and Sanskrit. ICT's University Song is written by him also. We are blessed to have this highly prolific personality in our webinar, and you are most welcome, sir. Please come and gratitude us with your precious lecture.
Thank you very much for this kind introduction. I hope I'm audible to all of you. And
Yes, you are audible.
thank you. So, let me start my presentation. Okay, so giving webinars of international type has become a routine for me, and since the lockdown has begun, I don't know how many I addressed so far, and I take a great pride and I'm privileged to address all these participants in today's international webinar on the role of green chemistry in controlling environmental and ocean pollution. Ladies and gentlemen, the title of my talk is Climate Change and Energy and Material Sources, Green Chemistry and Engineering in Carbon Neutral and Carbon Negative Technologies. And so why I'm also addressing, because apart from my role as a chair of the ACS International Chapter, I'm also elected as the president of Indian Chemical Society. And you know that this society was established by Acharya Prafulla Chandra Ray. So what are the new initiatives of ICS? Since I think that this society or the very world requires a lot of new ideas. So what is going to happen? Elsevier will publish the Journal of Indian Chemical Society from 2021 with an international advisory board, and using the editorial manager platform, we just struck a deal with them. There are new guidelines of fellowships because only fellowships were available. So there will be a new category of life membership where college teachers can certainly become life members. They can start their college chapters, and also there will be student members. There will be another category of institutional members where colleges and universities can become members of the Indian Chemical Society for promotion of chemical sciences. We have started a new category of corporate membership. There is a new bulletin which is Chemical Varta, and on 2nd and 3rd August this year, we will be celebrating Acharya T.C. Ray's birth centenary celebration, and the entire month will be devoted to various webinars. And so we have created a new website, and there will be an active collaboration with ACS and RSC because of my active association with both these associations. Ladies and gentlemen, if you have not heard about Sustainable Development Goals, then you would not be a scientist. These 17 goals are very important for the entire mankind. The number 1 is no poverty. Number 2 is zero hunger. Third is good health and well-being. Fourth is quality education. Fifth, gender equality. Sixth is clean water and sanitation. 7 is affordable and clean energy. 8 is decent work and economic growth. 9 is industry, innovation and infrastructure. 10 is reduce inequalities. 11 is sustainable cities and communities. 12 is responsible consumption and production. 13 is climate action. 14 is life below water. 15 is life on land. 16 is peace, justice, and strong institutions. And 17, partnership for achieving these goals. Believe me, none of these goals would be possible but for the contribution of science and technology. And in today's world, the boundaries between various sciences among various engineering branches have disappeared. So we can group this SDGs into 3. How do you make a lot of food? That means we have to use different types of fertilizers. We have to use genetically modified fertilizers and all those things without causing any harm to the human body and aquatic life. So you can see all the other sciences, we can group them together, and these are a highly science content issues. So without science and technology, and particularly the role of chemical sciences and engineering goes to be tremendous in achieving these goals. So this, the any newspaper today, you will have issues on energy, water, food, affordable healthcare, and environment. And your theme of this particular international webinar is on environment. Add to that carbon footprint, industry and infrastructure, sustainable development, and GDP. And we are talking about a $5 trillion economy by 2024. So what are these new challenges, changes, and opportunity? This is like a new Brahma, Vishnu, and Mahesh. There's a new trinity. That is, if you are confined in a small place, you have to come out of it. That means you have to have out-of-box thinking for solving any problems which you are facing. You have to take risks and you have to find a new opportunity. So never before have so many compelling technological problems have occupied positions of prominence in our system of values. Every moment something happens unexpectedly, posing a new challenge. Corona changed everything. A year ago, we never thought it would change our way of thinking, our way of carrying out business, the way we think, behave. Fear of the unknown and uncertain future in every human activity. This is what has happened. So I'm going to ask you a question. How did you begin your day today? Did you use any of these things? And these days we are talking a lot about hand sanitizations, PPE, and immunity boosters and whatnot. And at the same time, I'm sure in the morning you must have used your mobile phone. And before even praying to God, you must have seen what WhatsApp message you got or whether you missed somebody's call. That means these are materials and chemicals. Ladies and gentlemen, can you show any 3 man-made materials or products without the use of chemicals? So think of a beautiful house or think of any other thing. A price of 100 million pounds is waiting for anyone. So if you show that, you will get it. Nobody has got it. This price is there since 2001. Green chemistry principles have been talked a lot, but I'm going to tell you something beyond these green chemical principles. Why doesn't? Why not more than a dozen? And why? The actual idea came from 12, agrochemicals, all of which contain chlorine, and they cannot be disintegrated by easy means. However, this concept is not new, as many people, Americans, claim that they are fathers of this chemistry. That is disproved, and I have written an article on that. In fact, the green chemistry principles were given in Solvay process of 1865, which was the genesis of green chemistry as well as chemical engineering. And what are that process? It was this double decomposition. Take sodium chloride, coax it with calcium carbonate, and you get sodium carbonate and calcium chloride. However, in this chemistry, ammonia is not seen. And this is the best example of process intensification, absorption with reaction, drying, crystallization, and making use of seemingly dissimilar substances to give something. And that was provided as a means of, to avoid the use of the so-called the Solvay process because of the English Her Majesty's Inspector of Factories, George. He said that this is what we should do, and this was given during that time. Think of any material today through smart chemistry. We have regular materials, we have functional materials, we have smart materials, we have engineering materials. In fact, you do not see 70% of the chemicals of the shelf. The chemical industry is a consumer in itself. The only issue is that can we produce chemicals by benign methods? And the so-called green chemistry comes to the rescue. And how do we do that? The beauty and charm of chemistry is that the attributes that perhaps most distinguishes chemistry from the rest of the sciences is the ability of chemists to control the structure of matter at the molecular level, underlying molecular level. From complex natural products like vancomycin to nanoparticles and whole genomes. That is the beauty of chemistry. But the change, there is a paradigm shift in chemistry. Today's chemistry is not the earlier chemistry. Chemistry is increasingly shifting from structure to function, and chemists will need to develop better strategies to efficiently generate molecules, symptoms of molecules with desired physical, chemical, or biological properties in order to meet the biomedical, energy, and environmental needs of the future. This is very, very important. In fact, we'd like to develop materials which will be multifunctional. And it is not. Suppose there is a scent, it should be already there. Or there is a color change, it should be used through nanotechnology. So this is where the role of chemical and allied industry is very, very important. Our need for fuels, energy, materials, basic needs, luxury, comfort, quality of life, all is because of chemistry and the chemicals. We should thank, William Perkin, who accidentally found in 1856, the dye mauve. He went to synthesize things, but he found mauve. And that is the birth of modern organic chemical industry, and the rest is history at this. So now our government says, our Prime Minister says, we should be Atmanirbhar Bharat. You see, there are raw materials which are very simple. You may have crude oil, and you may have a natural gas, and you have air, and you have, sulfur. All these things are used to make commodity chemicals, then secondary commodity chemicals, intermediates, and the final products. They may be textiles, safe food for supply, transportation, housing, recreation, communication, health and hygiene, and whatnot. For example, your mobile phone contains 20 different materials, polymers, smart polymers. The silicon which is used cannot tolerate even parts per billion impurity. You can imagine the kind of separations I'm here to you. And now India can make all these chemicals, and we should not depend on China. That is what our motto is in these days. In this particular case, the importance of catalysis and continuous operation is very evident. Petroleum refineries produce something like 10 million to 100 million tons per annum processing. However, the byproducts there are not, less than 100 gram per kg product. The role of catalysis is maximum there. And remember, all these are continuous processes, and therefore they are safest processes. Go to bulk organic chemicals, it goes down 2 order of magnitude production capacity per annum. The byproducts form increase, they may be 5 to 10 kg per kg. The role of catalysis is average. Many are continuous processes. There are few steps, and this is a separate process. You go to intermediate and fine chemicals. Again, the scale goes down by 2 orders of magnitude. but the byproduct formation is between 10 and 25 per kg of product. Role of catalysis is less. They are protecting and deprotecting growths and whatnot, more than 4-5 operations. Often these are batch processes and they are less safe. On the contrary, on pharmaceutical or superfine chemicals, the production case capacity may be 10 tons to 1,000 tons. And the byproduct formation could be up to 1,000 kg per kg. And the role of catalysis is less. And these are batch processes, several processes, sometimes anywhere between 5 to 30. So there is an inherent risk on this production of pharmaceuticals. Perhaps you might have read during this lockdown, when the lockdown was partially lifted and chemical production was started, there were many accidents reported, unfortunately, because people not followed the safety precautions while producing these chemicals. So very important. Now let me shift gears and go to the primary energy world consumption in million tons of oil equivalent, because our economy is based on crude oil. So what happens? The consumption, if you look at that, see, we have renewable, part of the renewable, we have hydroelectricity, we have nuclear, coal, gas, and oil. And if you look at this, and all these lead to CO2 emissions, that means they are going to affect our environment. No matter what we say, we will still be using coal till the time of 2050. New gas but however, the dependence of oil is going to be there. It is predicted by BP Energy by 2054, there may not be any oil left in the Mother Earth. And that will be, of course, to extract that oil will be very expensive because the quantity will be very limited. So if you look at that primary energy sector demand, it is transport, the industry, non-combustion, and buildings. Many people would not know that almost 33% of oil goes into building construction, but we never talk of it. We only talk about transport section, that trucks and buses and our personal cars. At the same time, our industry is dependent on this carbon, okay, and that is the fossil carbon. So you see, in this particular case, slowly the percentage of renewables, the so-called biomaterials or biomass is going to be more. And why biomass? Because once you have exhausted this fossil fuels, whether it is coal or crude oil, we have to depend on carbon, which is coming from renewable biomass. And that is what is very important. So if you see that the global economic growth is driven by increasing prosperity in developing economies led by China and India. By 2040, India should be number 3 in the world. And that is going to happen. So global growth, if you see that the population growth, India will surpass China in terms of population. So our requirements will be also very high. So what do we do? Because our standards of living are going up, and therefore the energy demand increases day by day. And that is also, so you see that the increasing primary energy demand is increasing substantially. This is led to population growth, the energy intensity, and the GDP per head. So you see that. What is the alternate scenario? The world needs more energy to allow global living standards to continue to improve. The Human Development Index is also slowly increasing. And you can see that if you want, the Human Development Index should be closer to 1. But many countries are below 0.8. So you see, the share of world population consuming less than 100 gigajoule per head is by the evolving transition and more energy, 30% by 2040, this share is going to increase. Therefore, we need more of this. So the global energy system faces a dual challenge. That is the need for more energy and less carbon. So if we look at this particular diagram here, you see that the evolving transition tells us we require more energy. We require more energy for primary resources. At the same time, that should be less carbon. That means if you have less carbon dioxide. So this is where I'm talking about what is meant by the carbon neutral and carbon negative. Okay, carbon neutral technology, you may use biomass and the carbon cycle will continue. So this is what we have to see, that the oil demand Still, we'll have coal, gas, and oil, as I said. And in case of coal, we'll have to use clean coal technology. Even Government of India has a coal mission. What it means that you have undergone coal gasification, you convert coal to the alkenes, that is ethylene, propylene, etc. You convert coal to methanol. In fact, NITI Aayog says we should have the methanol economy. And you can see at the same time, there will be restrictions on use of plastics, the so-called single-use plastic. But believe me, now because of the COVID and the use of PPEs and the masks and whatnot, plastic has come to the fore. And I have been advocating, in fact, I've written pieces, my opinions, that plastic ban should be temporarily lifted and technologies for, handling this plastic waste, medical waste must be developed. And that is what is the need of the hour. So the scenario for increasing environmental concerns led to a worldwide ban on single-use plastic. But so this is what is going to happen in future. So you can see the buildings will account for 33%, as I already told you, and lower carbon intensity is the one which we are talking about. If you look at the world energy scenario, India is giving a lot of emphasis on solar energy, and rightly so. Thereafter, it will be wind energy, then we'll have nuclear energy, we'll have gas, and we still have, oil. So this is where the role of this Paris Treaty or Paris Accord on climate change must be seen. What it says that every decade, the temperature of the globe is increasing by 0.13 degrees Celsius per decade. So practically 0.013. And you see the climate change is real. And this is where you have to worry. It is not only carbon dioxide, but methane, the nitrous oxides and all that. In fact, yesterday there was a news that cows emit a lot of methane. And that is true because there is an anaerobic digestion in their tummies. So there we have two different sources of carbon feedstock. One is the non-renewable carbon with oil and natural gas. We are familiar with that, and it is coal. In the case of oil and natural gas, we will get some new supplies of oil. We will have better tertiary recovery methods. So this is where gas to liquid processes, highly catalytic in nature, will make a very important contribution. On the contrary, coal, it will be coal to gas and coal to liquid processes. This is again catalytic in nature. You go to the renewable carbon, that is biomass. We can do chemical conversion using catalysis, where direct chemical conversion of biomass into a lot of things, whether it is HMF, furans, and all sorts of things, lignins, and going to variety of things. Or your biochemical conversion, either fermentation or enzymatic routes, that is another, and the thermochemical processes where biomass can be directly converted into gas and or it can be converted in liquid. In these processes, particularly in biomass-based processes, the role of catalysis is very important. The two major reactions which will play this role is hydrogenation and oxidation. And this is where we need a source of hydrogen, and we also, of course, we know that is the best source will be water. So whether the carbon is coming from fossil fuels or biofuels, there is a need to convert CO2 into fuels, chemicals, and materials. My group has been working in this area extensively, and we have got several patents. Hydrogen is the cleanest fuel which can be produced from hydrocarbons or from water and can be used to convert CO2 into useful products. And treatment of waste biomass or clean biomass for food into hydrocarbon with the help of novel catalysts. And hydrocarbons can also be reformed into hydrogen, but still carbon monoxide and or CO2 needs to be utilized. So whether you have a petroleum refinery or a biorefinery, ultimately fate of that carbon is CO2. So in the case of biomass, that CO2, our carbon neutral or carbon zero industry, we saw that nature plays a role, the trees and other stuff will play a role, but on the contrary, when you have this petroleum-based economy, carbon dioxide has to be converted. And what are those things? So that is where the valorization plays a very important role. This is source from Intergovernmental Panel on Climate Change, which shows the projected concentration of carbon dioxide. You see in the year 2000 and the see year 2100 and see the year 22 2050. By that, the carbon dioxide in the atmosphere, ppm, will be almost 2000. Currently, it is 410. When the Industrial Revolution started around 1750, it was about 250 or something like that. Now imagine, this is carbon dioxide which is going to lead to global warming. So if there is no technological intervention, this will be destruction of the world, and that is what all these coastal cities will be under sea. So you see this surface temperature rise. So that rise will be 8 degrees C by that time. That will be end of the human civilization. Therefore, what we need, we have to have a carbon dioxide utilization cycle. Whether it is in atmosphere, whether it is coming up, power plants, we have to capture it, you have to convert that into some product, and again have these renewable sources. So this is where we have these two major sources of production of materials and chemicals. So one is the crude oil based, which is ethylene, benzene, toluene, xylene, BTX, and syngas. So this is where you will use crude oil, natural gas, and coal. This is the fossil energy carriers. On the contrary, the biomass will have cereals, grass, wood, and oil plants. From biomass, we can go to the precursors, which will be sugar-based like glucose, fructose, etc., polysaccharides, cellulose, hemicellulose, starch, and lignocellulose, and the other part which is normally not considered when we are talking about this so-called, this 2G bioethanol, etc., that is lignin, plant oils, and proteins. So you will have the platform chemicals. We know some of these platform chemicals. In the case of biomass, citric acid, linoleic acid, ethanol, methanol, glycerol, and all this formic acid. This will be our new sources of materials. So CO2, in fact, this is where the carbon dioxide refinery of this future comes into picture, and catalysis will play a role. Whether you have a photosynthesis with water, you create oxygenates, or you have hydrogen reaction, hydrogenation of carbon dioxide, which is a thermodynamically most unfavorable reaction, convert into hydrocarbons, do the refining, and make chemicals and fuel. This is where methanol, dimethyl ether, and formic acid, we have got several patents in this. So the carbon-based fuels, we already saw this. So better catalytic materials for conversion of carbon-based feedstock, waste minimization and process intensification, renewable sources of energy, and hydrogen as a source of energy and conversion of biomass into fuels and chemicals. My personal belief is that Government of India should base our economy on hydrogen. We should embrace hydrogen economy, because that is the one which will save us from many, many troubles. So look at the Indian oil import. This was 228.6 trillion tons of crude oil at $130 billion. And Government of India wants to reduce import of oil by developing new technology. And the renewable sources, whether they are solar, wind, hydro, coal to fuels and chemicals, or 2G ethanol, biodiesel, etc., this is where we have a lot of emphasis. So India's total global primary energy demand is about, it will be double to about 11% by 2040, which will be underpinned by strong population growth and economic development. And India accounts for more than a quarter of net global primary demand growth between 2017 and 2040. 40% of this new energy demand is made through coal, meaning CO2 emissions roughly double by 2040. Although we say coal is discouraged, coal will be a major source for us until 2050. So gas production grows but fails to keep pace with demand. So we are, that we are importing gas also, implying a significant growth in gas import. So India's energy requirement by 2040 will be 156% growth in Indian primary energy consumption, 11% India's share of global energy consumption in 2040, and 58% share of coal in India's power generation, and 116% growth in India's net CO2 emissions by 2040. So renewable energy consumption surges from about 20 million ton oil equivalent today to 300 million ton oil equivalent by 2040, which is concentrated mainly in power sector, sector, even largely by growth in solar energy. Despite growing renewables, coal continues to dominate India's power generation mix, accounting for 80% of output by 2040. So, how do you develop this economy? No carbon-based fuels and hydrogen as source of energy. Why carbon? Hydrogen? Because hydrogen is colorless and odorless, does not easily spontaneously combust. The ignition point is only 570 degrees C. Then this is the lightest weight, extremely low boiling, and high combustion temperature, and produces no flames when burnt, reduces greenhouse effects, and it turns into only water. So we develop in ICT, we have filed several patents, and ONGC is supporting this work for last 12 years now. So this technology we develop for hydrogen production has a huge potential to generate hydrogen at about 0.95 US dollars, which is 95 cents, without valorization of co-product oxygen. This hydrogen will be useful for the hydrogen economy, including ammonia synthesis, hydrogen fuel cells, electricity generation, and e-vehicles. It is also coupled with solar energy in our technology through molten salt. In other words, utilization of CO2, water, and catalysis will lead to sustainability. So, no carbon-based feedstock, water as a feedstock, importance of materials and analysis of hydrogen economy. This is what I'm going to do. Once again, catalysis will play a very important role. This is where we made fundamental contributions and filed several patents. This is pore structure is inseparable from convective, diffusion, interfacial effects that occur inside the pores. These effects are interrelated. We have done a lot of modeling also, whether it is coal, rock, soil, membrane, solid catalyst, buildings, roads, cells, skin, eye, etc. They are all interconnected pores. So we have surfaces, we have interfaces, and in all these cases, only connected pores matter. So the network of pores of different sizes and shapes and the network of fluids, that is what is fundamental issue here. So we can model this kind of studies. So continuous pore network providing very high surface area and uniform or non-uniform pore sizes, surface properties of the pore network to be tuned by surface modification during synthesis or using chemical method thereafter, and particles, whether they are so-called nanoparticles, functionalized or otherwise, to be dispersed on the support surface uniformly. Again, we introduce another concept called cascade engineered reactor concept. So instead of many reactors and separators, we can combine it in a single reactor and separator, provided you have similar type of catalyst. And this is where the role of engineering comes into play. So we can have collected biomass, waste system, and ultimately we can create all these novel catalysts. So we can see this. I already showed you this. So what I'm doing, oh my God, this slide is repeated, but okay. So here, look at the ethanol demand of projection in India. Government of India's policy on non-conventional resources, ethanol blending in petrol to be 22.5%. Our production is hardly 3,000 million liters. So that is not good enough. And so you can see that to increase the octane number, you have to add ethanol in the fuel. So what do we do? How do we use carbohydrate residue as bulk chemicals? Like, transportation fuel, whether vinyl acetate, butadiene, styrene, propylene, ethylene, bagasse, all these can be used for making chemicals. So you have one hand, lignocellulose crops like C5 sugars and lignin, and another is lignocellulose residues. Both of these can be used. In fact, we develop in ICT a technology called 2G ethanol technology, which to tell the farmers you don't have to grow sugarcane. We can take any biomass and convert that into sugar. So this is where you have this biomass. You have a sugar platform, or you have a syngas platform, which is the thermochemical, or you have design fiber platform. This can be the another. So we have thermal conversion, thermochemical conversion, biochemical conversion, and chemical conversion. And you can see the role of catalysis in all these things. And whatever remains as a biomass waste, we have to pre-treat it, then leads to simple monomers, bioprocessing, specific monomers and polymers, biocatalysis to short multipurpose polymers, and polymerization to make advanced polymer networks. So this is the biomass refinery, the pre-treatment, you have hemicellulose, cellulose, and lignin, and you see how many C5, C6 sugar-based, that is xylose glucose product we can make. And all these are very, very important. And we have patents in some of these areas. So lignocellulose ethanol pathway, similarly, you can look at the lignin structure. Again, you say that it is always having oxygen and hydrogen. So what do we do? So we can have lignocellulose feedback biorefinery, where you take lignin, hemicellulose, cellulose, and convert into a variety of things. Xylose, okay, xylite. All these processes we have developed. So pyrolysis of lignin-based oil you can do, and you get all sorts of very rich products, highly valuable products. So one of the things which we did is a cascade engineer catalysis, which I told you earlier. Here is a one-pot synthesis. You see that we have done synthesis of gamma-varoloractam, 1,4-pentanediol, and 2-methyl tetrahydroquinone from livolinic acid using novel paradigm copper based on zirconia in water as a solvent. So this is very important. You can produce, we can fine-tune these processes to generate any of these products. We published in ACS Sustainable Chemistry and Engineering. So like hydrogenation of gamma-valorolactam, you can see that again you can get pentane 1,4-diol, very important. Pentane 1,4-diol based polymers can be produced, or you have 2-methyl tetrahydrofuran which can be used as a fuel additive. So this valorization of succinic acid to gamma-butyroactam, another important product, and these are again based on dehydration and hydrogenation reactions. And how did we develop the catalyst? Based on the pore structure and the surface properties and a lot of mathematical modeling in this. So if you take vegetable oil, you always have biodiesel with a bioglycerol, which is 10%. And bioglycerol needs to be valorized in order to make value to biodiesel. Otherwise, it is only will live on subsidy. So acrolein or acrylic acid, 1,2-propanediol, 1,3-propanediol, epichlorohydrin, glycerol carbonate or glycidol. These are very, very important chemicals which can be produced on massive scale from bioglycerol. We did all this valorization of glycerol using variety of processes in our laboratory, and we filed a number of patents. We can see that you do many of these things are high level of science and engineering involved in developing these processes, and which we have done. So for example, glycol, once you make from glycerol, you can make ethylene glycol, and ethylene glycol becomes a building block of many, many valuable chemicals. So for example, if you take HMF as a platform chemical, instead of benzene, toluene, xylene, we can valorize it and create into number of things. So for example, take fructose to HMF, you can make livolinic acid or you can make the ether. So here we did some novel synthesis of 5-HMF from D-fructose, where synergy of ionic liquid and sulfone as a modified was done. You can see that this was based on heteropolyacids. In fact, we are one of the leading authors in writing papers on heteropolyacids. So you see our microwave assisted one-pot synthesis of 5-ethoxymethyl using deep eutectic solvents. Okay, you see that this is also very important. It goes into biofuel. Or you take HMF, which is a platform chemical, and you can produce a galaxy of chemicals, all of which are very, very important. One of them is 2,5-furan dicarboxylic acid, which is a highly sought after chemical. So you can make bulk chemicals like livolinic acid, gamma-valorolactam, furan dicarboxylic acid, and dimethylfuran. We have patents in this area. One, for example, the selective hydrogenation of 5-hydroxymethylfurfural to 2,5-dimethylfuran using magnetically separable iron palladium on carbon core shell structure bimetallic catalyst. You can see that, in fact, this is a very interesting paper which we published in green chemistry. We have seen this another work, similar product, but we use a different catalyst, where we palladium and cesium modified heteropolyacid with cesium using K10 clay as the catalyst. Or magnetically separable sulfated zircon as highly active acidic catalyst for selective synthesis of livolinic, ethyl livinate of furfural alcohol. You can see many of these things are based on high level of science and engineering. So we have done many works in this area. like selective synthesis of furan dicarboxylic acid. This we use using manganese ferrite. You can see that catalyst also very important catalyst. So hydrogen production water, I showed you the specific energy of hydrogen is very high in comparison with the rest of the fuels. And so there are many ways by which hydrogen can be produced. And industrially, hydrogen can be produced from variety of areas. So if you look at the hydrogen source and natural gas, propane, biomass, coal, methane, wind, solar, or uranium, and see variety of hydrogen, ultimately the hydrogen is going to be useful for, the so-called carbon negative production. Hydrogen production based on thermochemical, electrolytic, and photolytic processes. Thermochemical processes is high temperature water splitting, and the electrolytic like PEM electrolytes, alkaline electrolytes, all those things are there. So biohydrogen production is based on fermentation and biophotolysis, and you can see these are all well-known processes. So steam reforming of natural gas, you see this is 48% of hydrogen is produced by steam reforming of natural gas, which contains methane mainly and ethane, all those things. Our coal gasification is 18%. Water electrolysis is less, and other sources is 30%. So you can provide this energy in the case of thermochemical processes. You can use nuclear energy or use some other source to produce hydrogen. So you can see it is not only producing hydrogen, but where do you store it? So you can see that highly compressed gas has to be used if you want to have a hydrogen vehicle. Or you need some storage like some hydrides, metal hydrides, where you can have certainly hydrogen stored. So hydrogen market will be tremendous, like chemical processing, petroleum recovery, refining, metal production and fabrication, aerospace and fuel cells, and hydrogen demand is the largest in petroleum data. And hydrogen fuel cells can be used to generate electricity. And so the wells to wheel efficiency of hydrogen vehicles, you can see that hydrogen fuel cell has 40% efficiency, grid to water efficiency 25%. So you can see everywhere the efficiency matters a lot in all these things. And we are also talking about lithium ion battery when you want to store energy. So in the case of this fuel processing of gas, liquid, side type of fuels for hydrogen production, this is a general flow sheet because I'm a chemical engineer. I can tell you that how do we do it in industrial, and this is very important. You can do the same thing for biomass to hydrogen. So ethanol, butanol, glycerol, and ethylene glycol, we did this work. We have published all of this thing. Ethanol reforming, glycerol reforming, and you can see number of these reactions, N-butyl reforming, and all those things. That means reforming, you can do steam reforming to produce hydrogen. The steam reforming of ethanol, we develop novel catalyst. We ethylene glycol reforming, also we develop novel catalyst. We develop many other type of catalysts. I'm not going into the details. Ethylene glycol as a feedstock, again we develop novel catalyst. So now here I want to compare the reforming technology. Steam reforming is the most extensive and industrially experienced technology, and methanol is used extensively. Then autothermal reforming or partial oxidation. These are the three technologies used for reforming processes. And so in the case of thermochemical process of water splitting for hydrogen, there are more than 216 cycles. Its sulfur and iodine cycle is very widely. Then cerium chlorine, vanadium chlorine, and copper chlorine. We studied both sulfur iodine and copper chlorine solvent. We have a series of patents in this. This is where the work was supported by ONGC. And you can see that I will not go into the details what we do. Ultimately, copper chlorine cycle was coupled with solar processes. And you see that, look at the technology maturity. Steam reforming is maximum use, then partial oxidation. Then you see that biomass gasification and alkaline hydrogen, these are all commercial processes. All others are laboratory processes. So if you look at the pricing of this, it will range anywhere between $2.27 per kg to something like, 2.13. So you see that in all these processes, whether the energy source is solar or nuclear or something else or wind, we compare our technology with the published work and we can produce hydrogen as 95 cents, which is much cheaper than the other sources. So this is how now we are going for a big pilot scale process, and then we hope to take it to commercial scale where 70% of India's needs can be met by this technology. So this is what the solar hydrogen, we can make the various comparison of this, and we find that reforming, electrolysis, byproduct hydrogen which comes up this soda, so caustic soda industry or iron industry, that is one which is available. And the future technologies will be coal gasification with carbon capture and storage, thermochemical cycles, radiolysis, and thermochemical biomass. So this is where the technology stands today, and we, as I told you, that technology maturity, our process is the best. Okay, the cost of electrolytic hydrogen, you can see that it is said that small plant, this is US Department of Energy, this is their projection. And this projection is based on large number of things. The copper chlorine cycle, we got patents in all these leading in countries of the world because of the innovation in that, and this is where we have been successful in getting the cost of production of hydrogen to minimal value. So what the Department of Energy says, it says that hydrogen economy in near future, lot of things are going to happen. High temperature electrolysis, gold gasification with CCS, and all this solar thermal hydrogen, carbon. So what we see that long-term prosperity of hydrogen economy will be electrolysis from renewables or nuclear becomes important, or the technology which we are developing. So this is one of the stages where our technology is there. And if you use these novel catalytic technologies in near future to arrest the climate change from carbon footprint in all applications, you can see that in this particular case here, we see this is carbon neutral. So from almost 2036, we will have carbon neutral, and that will arrest the temperature. So my personal belief is that lot of work will happen in next decade or so in this particular area, and then there will be many giants participating in carbon neutral technology, and not only carbon neutral but carbon negative based on hydrogen. So the ideal goal is to contain climate change, and ICT's efforts are in that direction. So we can see, so this is what ultimately the so-called circular economy, that there is nothing waste, but everything is converted. This is a system engineering approach, that is only materials go in and useful products come out, and everything is recycled, unlike in the linear economy. So what is ICT's carbon neutral and carbon negative products? We have used solar energy. This is, this box is molten salts or any other source. Copper chlorine cycle, where water goes in, you get hydrogen and oxygen. So oxygen can be used for biomass conversion. From here you can use hydrogen to CO2 conversion or biomass, and we can convert hydrocarbons, methanol, dimethyl ether, formic acid, formates, syngas. Syngas can be used by Fischer-Tropsch synthesis to make many chemicals. We can make alcohols, ammonia, fuel cells, hydrogen and electricity. So this is what is the future of energy and materials. We have written a very big paper on this, thematic paper on this. So the future of chemical feedstock, environment protection, and combating climate change, nothing is waste but wealth. Carbon neutral or carbon free processes. CO2 should be valorized using novel catalytic technology and multiple reactors. System engineering approach, that is only useful products and energy leave the system boundary. Waste biomass, plastic, woody biomass, etc. will be sourced. Nature will be our guide. So carbon dioxide, water, sunlight, and catalysis by chemical and biological species. This is what is going to be. So I must thank ONGC Energy Center and my fellowships and also my professorships. And this is work done by a lot of students in my lab. Although I have formally retired, I have a huge group, almost 40 students working on all industrial projects. I have not taken any government money. Thank you so much for your, and I also want to tell you that I'm editing this catalysis in green chemistry and engineering, which is published by Begel House in New York. and this is international editorial board. So those we are, you can submit your papers over here. Thank you so much for this is the international board coming from all parts of the country. I'm in all parts of the world. You have Roger Sheldon, we are Rajendra, Verma, we are Sasaki, and all those people are, or CJ Lee of Maggie University. So with these few slides, I conclude my lecture and will be more than happy to answer any questions which the audience has. Thank you so much once again, Gangashil Mahavidyalaya, and thank you, Madam, for giving this opportunity to me. Thank you.
Thank you, sir. Thank you so much for the most informative session for our listeners. And if anyone has any query, you can ask or message us in chat box. Sir, we have one question from Mr. Om Prakash. Biofuel can play a vital role in transport and industry sector.
Listen, you know what it means? Carbon, my personal expertise, I will tell you. Yes, right now we are giving a lot of emphasis in India on biofuels because we want to reduce the import of crude oil. And right now we have a lot of carbon sources, like, the agri-waste, for instance. So you can use it, but in the long run, carbon should not be used as a fuel. We should have renewable sources of material, whether it is solar energy, wind energy, or water to produce hydrogen, so that the impact on environment will go down. And this carbon should be used only for materials and chemicals and things like that, and not as a fuel. Fuel is a bad idea for carbon. That is what I showed you, that the slide on carbon dioxide, and what will happen if there is no technological intervention. Carbon dioxide emissions will increase because our energy needs are going to grow day by day. So this is the, this is my theme of my research. Okay.
Thank you, sir. Thank you for giving your valuable time to us. And in continuation, I would like to invite our subject expert of today's international webinar, respected Professor A.K. Chakravarti, sir. He is the visiting professor in IIT Ropar, Punjab. He is gold medalist in MSc for obtaining highest marks in chemistry. He got Bardhaman Sammilani gold medal. He works as assistant professor in Department of Medicinal Chemistry, Nipur, Mohali, Punjab, and become associate professor and then professor and head in 2001. He got Ranbaxy Research Award in 2004, and he and also Eminent Mass Spectroscopist Award in 2019 by Indian Society for Mass Spectroscopy, and Best Research Guide Award from 2015 to 2018 continuously. He is a member of editorial board of different journals as Asian Journal of Life Sciences, Journal of Pharmaceutical Sciences and Emerging Drugs, member of the board of government organizations. We welcome you, sir, and you're most welcome in our webinar. Please come and gratitude us by your kind words. Respected Professor A.K. Chakravarti, sir. Sir, please unmute your speaker. So your screen is presenting. Please unmute your speaker.
Is it unmuted now?
Yes, sir.
Okay. Can you see my slides?
Yes, sir. It is visible.
Should I start now?
Yes, sir.
Yeah, first of all, I thank Dr. Pankaj and his colleagues in Gangashil Mahavidyalaya for my interaction with the participant for this international webinar on the role of green chemistry in controlling environment and ocean pollution. So, what is the environment, right? So, generally by environment we mean the water jacket around us, but it is not only the environment, and rightly ocean has been attached to this theme. What is also a very important component of the environment, because most of our food chain is through the water. So we have to be very much careful in water pollution also. Although most of the cases it has been mentioned that how it is being polluted. I'll give a couple of simple examples for that one. We'll see that one, that among all the pollution, it is the chemistry related activity, whether it is done by the chemist or by a chemical engineer or any end user of the chemistry. So ultimately all the chemical activity, whatever we do in making materials, which might be for health maintenance or it might be for our comfort zone, etc., all are the cause of the pollution. But when we talk about the comfort for that one, today we are used to air conditioning system, we are used to motor vehicles. So their emissions do two types of pollution. Number one, they can contribute to whatever we call the global heating or global warming. But most alarmingly, what they can do, we generally release a CFC, chlorofluorocarbon, to the atmosphere. The first layer of atmosphere which provides us oxygen to breathe is troposphere, and next is the stratosphere, and is a very strategically very important component of the atmosphere. Here is the case we call that ozone layer, which protect us from the adverse effect of the sun radiation, particularly UVB radiation. And these chlorofluorocarbons, which are normally photolyzed to generate the radical, same thing with the nitrous oxide also, but major pollutants are the CFCs. So they deplete the ozone, and that has become a major environmental challenge globally because of the depletion of the ozone and the generated ozone hole. So the chemistry has done it, and at the same time chemistry has put out the solution to that one, of course, through regulatory agency like Paris Convention, which is very meticulously followed by New Zealand, but our country is also very much dedicated towards controlling the pollution for that one. Today, in this year report is like that one, the ozone hole has been completely rectified for that, and this is only because we have found out through again chemistry knowledge that what is the most non-polluting replacement of the CFCs are called HFC. We'll see that one, that chemist again or chemical products again is a major pollutants, and how to control, we'll see that one. Ultimately it is going to come one exercise in the chemical domain which we are going to nickname or call the name as a green chemistry. Professor Jadhav has mentioned many of the things in E factors. Normally when you do any chemical reactions for the purpose of getting a product, which is maybe a drug molecule, which might be any other utility product also, and in addition to generating our desired material, we do generate a lot of undesired material which are called waste. And this is a simple one part of examples of the chemical waste, and normally the amount or quantification of the waste is given by a green chemistry matrix called the E factor. I will not go the details for that one. And this is one aspect of the contribution of the E factor for the chemical related action, like either oil refinery process, it is also a part of the chemical, only it comes under the petrochemicals. Remaining three criteria, you see the bulk chemicals, fine chemicals, or pharmaceuticals. These three together comes under the pharma sector activity, and you see that they produce a lot of waste. And all those things, central stage is the chemistry, or how we do manage the chemistry, how we use the chemistry for the benefit of our health system or any other need, without adding major detrimental effect of the environment. So it is under this backdrop, I thought that one I'd like to discuss with you the role of green chemistry in drug discovery and development in the context of environmental pollution, because pharma sector happens to be one of the major polluting chemical industry, and we cannot do away with the production of the pharmaceuticals. So then, of course, green chemistry, why Professor Sharma has very nicely given you for that one, so I will not go details for that one. So ultimately, objective of the green chemistry is like that one. The sustainable way of doing the science is the barrier of any doing the science. When it comes to the domain of chemistry, which is called green chemistry, ultimate objective or motto of the green chemistry is to protect the environment out of the adverse effect of the chemical exercises, and that's the reason green chemistry is the major driver of the development of the modern chemistry. And in the pharma industry, people have been very well made aware about that one, about various kinds of publication, like this is a very good publication related to the pharma sectors, green chemistry tools to influence the medicinal chemistry and chemistry research-based organization. I could see a lot of questions are coming that can we do this thing? This is a very important articles, at least for the people who want to practice green chemistry in academia. So read it, you'll find out a lot of things, how we can address this thing, even if you are in a Gangasil Mahavidyalaya doing your chemistry research or activity. This is another example. So it will tell you that in day-to-day activity, chemistry exercise, what we do it, how we can contribute in a smaller way, which can be integrated in a larger way to contributing to the green chemistry principles like that one. These four gentlemen are the CEO of all the top-notch pharma companies. What they have done, they have taken the best-selling pharma product, all the drugs of their companies. They are originally were chemists. What they have done, they have analyzed each and every step of the synthesis of those drug molecules, what are the chemistry involved, and you will get lot of impetus that how we can contribute to the green advantage of the chemical research. In the domain of medicinal chemistry, and which is my topics for that one, and almost all the pharma school do that one. Unfortunately, in the medicinal chemistry exercise, we try to do everything other than the chemistry, thinking that one, every chemistry has been done and we have nothing much to do in the chemistry. All we have to do, take the known chemistry and make some of our compound, give it to our pharmacologists, get the biological data. Just to sensitize this kind of mindset, this article has appeared in Journal of Medicinal Chemistry, which tells you, I do not have I don't know whether you will see or not. Can you see this one? Like it says that one, there is a need to further improve already tried and tested procedure which are widely employed, but where there is a clear deficiency in the areas such as atom economy and safety. Of course, cost also will come in the picture. So you have a lot of scope to contribute to the new knowledge of chemistry, even if you want to try to adapt the already existing chemistry. So what has been highlighted by this expert through these particles, that while making your pharmaceutical in the synthetic strategy, two major exercise of chemistry they are projecting as a green chemistry initiative. One is CH activation. I will talk about today's discussion in this regard. We do contribute a lot of in this regard, and aqueous chemistry, which has been come very repeatedly for that. Now, why aqueous chemistry? Now, why addressing, since the bulk producer of the chemical products at the pharma industry, so that's why it has been a bottleneck or maybe the major headache of the pharma industry, how to address the sustainability in terms of the green chemical processes. And they found out there are 5 straightforward priority targets in the R&D. If they address those things, probably bulk of the problem can be sorted out. And see that it says that one, that Professor Jadhav repeatedly mentioned about the power of the catalysis. So you have to adopt the catalytic reactions. Of course, multi-step to fewer steps so that your exposure and the waste generation each and every step can be reduced. I draw your attention to the 5th agenda under this slide called improvement of this reaction media. Means you do not use a solvent. You can do a solvent-free reaction, but solvent-free reaction will have a tremendous problem in the mass production because of the heat transfer will be very difficult to manage for that. And same thing is applicable to the solid-state reaction. So what we need to look for that one, that alternative to the classical organic solvent, I will show you a list for that one. So what are supercritical media? One example has been given by Professor Sharma. Ionic liquids, a lot of questions for that one, and now deep eutectic solvent is coming. It was not in the focus when this was for that one. And of course, a higher atom utilization means catalyst will going to address that issue. You reduce the waste production. So under this backdrop, so when we try to do anything in our research, we try to address these 2 prior agenda of the green chemistry: alternative reaction media, water, ionic liquid. And I'll talk about ionic liquid, fluorosolvent. I'll give 1 or 2 examples using water. And catalytic processes like solid protic acids as a recyclable catalyst, heterogeneous catalyst. CH activation I will talk about today, and nanocatalysis. I'll take one example in this regard. Professor Jadhav also mentioned that on strength of the nanocatalysis. So why the manipulating the solvent is very important. Now, although it is a old slide, I didn't get an update in the public domain so far. It says that one in Europe, the total use of the solvents, which are classical organic solvents, is 4 into 10 to the 6 tons. Normally, these are organic solvents supposed to be recovered by distillation, but their recovery efficiency varies from 50 to 80%, average is 60%. So, where does the remaining percent goes? It goes to our air, and it goes to the water and ultimately come inside you. So you have to know how to manage a solvent. So there has been a major emphasis in the pharma industries. They try to make various ways to determine the solvent selection guide, and this is the Pfizer solvent selection guide. So what they have done, they have classified all the common organic solvents which normally we come across in three categories. The first one, the green one, is the preferred one, middle one is usable, and the last one is an undesirable one. And you'll find out that one, most of the solvent which at least I was used to when I was doing my PhD studies or even MSc or BSc practical are the commonly used solvent for that. So what it says that one, that water is actually the top of the list, and probably water is the ultimate green solvent. And as I mentioned that one, when we were training the PhD in early 80s, we were told indirectly that stay away from this entity in your laboratory doing a reaction is water. So alternate reaction media we try to put use whenever we do the work is use of water. I'll talk about that on use of anionic, a different form, and a fluorous alcohol. So we try to make use of those things wherever it is feasible. We come back to the water. As a matter of fact, incidentally, that the very first organic synthesis was done in water called Wohler synthesis, which gives a misnomer to the organic inorganic classification. Ammonium cyanide to urea was carried out in heating in water, and it happens to be 100% atom efficient reaction. So it looks like that one, without telling a green chemistry matrices for atom economy or the hazardous substances, inherently in the synthesis of chemicals, those two parameters were there only. It took such a long time for us, more than 100 years perhaps, to recognize that what is the implication of that one. So it came to the knowledge of the organic chemistry in a very comprehensive way in around 1930s, when the first Diels-Alder reactions was carried out in water. It was found out that there are a lot of advantages, so much so in 1942 a patent was filed in performing Diels-Alder reaction in water. Certainly they visualized the implication of water as a reaction media in years to come. But credit goes to Ronald Breslow in 80s to make it a common knowledge to synthetic organic chemists, and after that only the use of water in organic synthesis started becoming popular. So what we realized that one, before we started delving into the putting water into our greener ways to make whatever we want to make it for that one, that is there any advantage in using water replacing the classical organic solvent apart from the pollution kind of things? Yes, it was found out that one, in fact, replacing other organic solvent by water, there is a distinct examples where the rate acceleration takes place. There are examples in which there is selectivity when you are supposed to get two products, probably one product is obtained. And in view of this one, there has been a lot of example in organics, particularly intermediate synthesis using water. But what we realize that one, all the three types of examples are basically concentrated to one particular reaction, which is a Diels-Alder reaction. And then what could be the molecular level mechanism or exactly how water is doing all those benefits? So it has been projected, it might be hydrogen effect and occasionally hydrogen bonding effect, but all of those in concentrated to the Diels-Alder reaction. We try to find out that whether can be any generalized way to think about a beneficial effect of the water in carry out other than the Diels-Alder reaction. And we try to think about what could be the molecular level interaction of water with the reactant, so that there will be a rationale behind us to choose a water for a solvent for a particular reaction. And we focused on this particular reaction, which is nothing but a very popular reaction, not only to synthetic organic chemists, to the biologists also, peptide chemists, that in block protection normally we need to take a catalyst. 4-dimethyl aminoprotein till lately was the popular catalyst, but extremely bad catalyst. It is a mutagen and a lot of adverse effect is there. So found out that it can be performed by without taking the catalyst if the reaction is performed in the water, and the reactants are an amine and Boc anhydride. Now Boc anhydride can be activated through hydrogen bond formation reaction, and then amine also can be activated through hydrogen bond formation reaction, so that we can make through the transition state 2 and the reaction can take place. This is a self-indicative reaction. As long as the reaction goes, there is a effervescence of carbon dioxide, and once the reaction is over, if it is a solid, it precipitates out. If it is a liquid, it will either float or settle down in the bottom for that one. You don't need any additional purification techniques, simply filter it out, decant the water, and maybe air dry, you can get almost analytically pure water. So we have contributed to we have attributed the role of the water as a dual activation. This is an activation of the electrophiles hydrogen bond, and this is another activation of the nucleophiles, so another hydrogen bond to the oxygen atom of the water. It says that one shallow does not make it a summer. Is it only applicable to one type of reaction? Again, due to some of our need to make this kind of molecules, which I am going to talk about today for that one, this can be, and we want to further modify that for our drug development purpose for that one. So we realize that one, there has been a lot of catalysts, and we have also developed maybe half a dozen of catalysts, metal derived catalysts to make the thermochemical reaction. But ultimately, the final product we want to subject it to enzyme assay, and enzymes are very much detrimental to the presence of trace amount of the transitional metal impurities. And since sulfur is present in the product molecule, it is a very, very strong absorber of even ppb level of the metal source. So we required a process in which a completely metal flow process, but at the same time it should have a catalytic activity. So we thought that one, whether we can put into use the role of water for electrophilic nucleophile dual activation, and the job can be done. In fact, the reaction goes for that one. So these two examples, we did have a confidence that it is possible for us, depending upon the combination of the reactants, we can make use of the water as an electrophile or nucleophile dual activation. I'll show you later on that we need to focus on this kind of benzothazole, and benzothazole can be obtained by a combination of that one. And a lot of catalysts are there. Initially people used to have PPN, etc. None of them are going to qualify in today's definition of the sustainability. We realize that one, the same reaction can be done without use of any metal catalyst by heating. Then we have started utilizing reactions. Then we were a little bit critical. We found out the second criteria of the sustainability index is called consumption of energy is not being fulfilled properly. So we needed to carry out the reaction room temperature. So we found out S-DOS. I will not talk about the chemistry. Generally, people use S-DOS merely for the use of a solubility enhancers of organic compounds. We did find out here the completely different chemistries involved, but I'm not going to talk about that. So we had room temperature way to make the final product for that one. And we found out that yes, we can integrate our findings, which is called a academic research, etc., in putting into the practice in our medicinal chemistry exercise to find a new anti-TB lead. We know that one, tuberculosis is a global disease. Earlier it was a poor man's disease, but because of its airborne nature and because of the traveling for that one, it is not anymore a disease of the Indians. Everybody is concerned about that one. So now everybody is looking for a drug, but it took 40 years after rifampicin, isoniazid, those things for bedaquiline to come into the market. Still it has a lot of problems, but it is a new direction in the anti-TB research. So naturally we are looking for a new type of compounds, and we focused on benzothazole both because of the prior indication for that one. So what we did for that one, that if we found out that one, this amide moiety is present in our classical anti-TB drugs also. So if we can incorporate that, so it's called classical medicinal chemistry, it's called scaffold hopping. So we found out this can be a target molecule. So now we come that how to make the compounds. Again, the first step is going to be the condensation reaction of ethyl glyoxal with 2-methoxyphenol, and we put into use our aqueous mediated reaction. So no catalyst, etc. for required. We get the starting material. Next time also we have to make a transamidation reaction. We didn't take any catalyst for that one, simply ammonium chloride without solvent, heat it for that one, and the final products are obtained. So in the initial phase studies, we have prepared 41 compounds, and they are subjected to H37RB anti-TB activity. Although we are glad that we did get a lot of good heat. Normally it should be minimum 6.25 microgram per ml to even claim that it is a heat. So we did get about 10 plus around 17 heat molecules. The best molecule is this one. So we realize that with a very limited, very active molecule, it will be very difficult for us to proceed further. At one stage, probably we have to drop it. So we are looking for that how we can make it further modification of structure so that we will get a larger, better heat. So we looked into our design, and then we found out that one way to improve the activity probably will be that can we adapt some of the structural scaffold which are present, and pyrazinamide is present in the linezolid. At that time linezolid is antibacterial, but now linezolid and sulfazolid, they have been approved for the combination therapy for anti-TB also, and they have a pyrazine as one of the important pharmacological feature. So we thought that one, why not to club pyrazine through the amide, and let's see that whether we can get it. Again, the first step is going to be to take advantage of the S-DOS mediated aqueous chemistry to make the stock material. And this also is ammonium chloride mediated reaction. This is also green chemistry. For that one, we have not taken any transition metal catalyst, and we did get the target compounds, and those were subjected to this thing. And in fact, we did increase the number of hits, like it one molecule at the 0.78. Generally, you need to have a half a dozen of the best active molecules so that ultimately you can have a one backup molecule. So we realized that one probably still we are yet to get the optimized structure. Then we thought that one, what we can do now, there is a very limited scope of interaction of this portion of the molecule except the carbonyl compound with the target site. I will not talk about the target because this we want to patent it of target identification has been done. So we found out that a more structural varieties can be obtained if instead of taking a aryl alkyl or simply cycloalkyl, if you take aromatic moiety. Only problem, the ease with which we are getting the transamination reaction for the aryl alkyl or cycloalkyl, that same ease it didn't work. So we have to adapt a little bit lengthy route for that one, and we have developed a new chemistry also. I will talk about this one. This is undergoing various phases of patenting and etc. So we did synthesize a large number of compounds, and those were tested. In fact, from one best hit we can add it to 4, and now we have 9. As I mentioned that one, that we are now squeezing out the molecules, and we know that one what is being the target, and many of the molecules we have subjected to the INH resistance and RIF resistance cell line, and they are showing very good activity for that one. So we see that one, whether we can get a co-crystallized structure of our best molecule with the drug target, then we can take it further for that. So this is regarding the medicinal chemistry exercise. So that is the discovery phase. Now come development. Development means called process chemistry, and I have talked about, I have started with water. Although if you do not pollute the water, but can you make use of the water by replacing the other water polluting substances like volatile organic solvents. So I demonstrate you a completely all water chemistry for 2 or 3 drug molecules. Ranolazine is apparently is not that much complicated molecule. Only structure is big, but not much that much complicated to synthesize. And it has been approved in 2006 for US FDA, and it has a new way to treat the cardiovascular diseases. So we are interested, but that is not the reason we are interested. While doing the patent search, we found out that lot of patents are being filed from the United States regarding this molecule. And when we tried to go through the patent to find out whether it is a completely new chemistry, there are one Indian pharma industry also, they are actively in filing patent in the US. We are surprised to notice that none of those patents has at all to do whatever we talk about the chemistry. What they are trying to do, they are trying to find out a right combination of the solvent for crystallization so that they minimize the impurity at the final level. That means the original way the molecules are synthesized, there is a impurity associated with them, and as per the new US FDA rule, the impurity has to be 1%, and what is that 1% you have to spell out, otherwise you will not get the approval. So that is the reason they are trying to do that. So then we thought that if that be the case, why don't you attack the root cause of the issue for that, which is that how the molecule is synthesized. Then we realized that this is the final molecule, they have a different component, this component, this component. So how these individual components are assembled in the molecule, and then we realize there is a problem for that. So this component actually comes through the epoxide opening reaction, and all of them started with that reaction first, and we realized that is and most of the impurities carried forward the final product is due to the impurity coming from the side reaction for this epoxide opening reaction. So we thought that let's do one thing. We install the epoxide related fragment at the last as late as possible, so that in the final stage minimal purification efforts we can get a better product. So with these we have revised completely redesigned the synthetic routes, and each and every step the reaction has been done only in water. There is no catalyst. When we claim water, we do it that whether the same reaction can be performed if equal is means percentile and etc. in any other solvent. If it works, then we do not claim the water assisted reaction. It does not. I'll show you the data. So each and every reaction separately has been performed most of the common organic solvent, and there is a distinct advantage in terms of the product yield, more importantly in terms of selectivity, that means minimize the byproduct, but practically is nil, less than 2% and etc. And that is eliminated when we do the purification techniques like crystallization. In fact, the reaction can be, so basically it is a two-step process, and the overall yield has been increased from 36 or 34% to 77%. Anybody who knows about the overall yield is a leapfrog jump into the overall yield. For that is only two-step process. Ultimately, now here we have to take this, the pyrogen molecule, there are two nitrogen, one nitrogen has been protected as a block. We found out that can we do this thing that we do not have to depend upon the deprotection state, which is another way also to do little bit greener process so that you can eliminate one step. And we found out that we can take it and one pot reaction we can do, and it gives 69% overall yield. Although I have demonstrated this thing RS, but we have a data that both works with the active compound RNS, but since the racemic is the active drug, so that's why we need not to bother about whether it is acting, but it works with the optically active metal also. In that case, epichlorohydrin, which is one of the starting metal, you have to take a chiral epichlorohydrin. So next example I'll give you luminazole. It is probably the best molecule to target for a process development because the molecule is yet to come to the market, but it is yet to get approved as a drug. So certainly one day it is going to come in the market. So it's better you be prepared for that one. And it has a versatile mode of action. That is the reason it becomes a hot topic for the medicinal and process chemists. So we also realize that one. This can be made as far as possible. The entire reaction can be in water, except one step for that one, last step, in which the reaction has to be carried out in ethanol. But you know that one, ethanol is the next best solvent in the pharma selection guide of the Pfizer. And all those things we have patented, and the patent has been granted also recently. This is 2019, and we are in dialogue with the industry to the process for that one. So we found out that a very concise route can be obtained by following this procedure, in which earlier what happens, people were introducing the epoxide ring via phenol reactions. We thought that why not to introduce that amino alcohol moiety through the amine reaction, so that becomes our completely different process for that one. And here also the reaction works with optically active material because the chiral compound is going to be drug in this case. So we demonstrate first with the RS, but ultimately we have done with the S compound, and it works very well for that. My last example will be, can we take advantage? You know that one, the nanocatalysis has a hybrid advantage of the heterogeneous and homogeneous catalysis. So catalysis have a distinct advantage in the green chemistry or green way to make the material. And as a solvent, I try to demonstrate that one, that water also provides you a greener way to make the molecule. Only thing is that one, we simply do not use water as an alternate solvent. We try to extract the chemistry water can add on, so that the reaction has additional advantage in terms of the catalysis or the reaction accelerate. So we thought that is it possible to extract the benefit of the nanocatalysis as well as water as a reaction media, means double benefit for the purpose of green chemistry. And being a medicinal chemist, we had a lot of that kind of issues. This scaffold A is a very versatile scaffold because it is present in these are the 6 drug molecules representative, and diverse kind of therapeutic molecules like the beta blocker, like the CARP expectorant, etc. This fragment, which we call pharmacophore in the language of medicinal chemistry, is present. And how do you make it? Now you can only make it that if you have the corresponding epoxide and do the epoxide ring opening reaction to the phenol, and there is a problem for that one because phenols are very poor nucleophile, and only a handful of catalysts were there which are very costly rare earth derived catalysts for that one. So here we thought that is it possible to take advantage of the nanocatalysis. Why? Now we know by this time that gold nanoparticles, they have a capability to polarize the lone pair of electron, at least in sulfur. So we thought that one, that if we can now, gold is a soft metal, so if we take a hard metal, make a nanoparticle, and since oxygen is harder than sulfur, so can we take a hard metal derived nanoparticle and try to polarize the lone pair of oxygen atom so that it will be activated? And we found out that one, the reaction works in water, and both water as well as the nanoparticle is responsible so that the reaction can be proceeded via the formation of the transition state 1. It was not possible to demonstrate this one because it cannot be added, and mass spectrometrically also it is very difficult to identify for that one. But whatever the reaction rate, substrate data, etc., we have a reason behind to do that one. But we want to tell it over there. By this time, Dr. Narahari Sastry, who is now the director of Jorhat, for that one, so he has proposed a model which is called cation pi interaction, and that gives a lot of advantage of carrying out a lot of reactions for that one. This is perhaps the first model, although we didn't claim that strongly because we didn't have not much evidence to do that one, only logically for that one. What was found out? This is a neutrophilic ring opening reaction, but if you take a competition between paranitrophenol and phenol, for which paranitrophenol is supposed to be poor nucleophile, the reaction takes at a much faster rate in paranitrophenol. And reason behind that one, that here is a case, there is a backbonism, that this becomes a 8 kind of species, because the moment it is getting electron density, it normally is supposed to be a neutral metal, but it is going to be a little bit electron rich, and it pushes the electron density through this aromatic pi cloud, and that's the reason nitro is going to be the better acceptor. That's why it's called anion pi interaction. But since our objectives are different, we didn't make a distinct claim for that one. The reaction works very well, and we could prepare all the drug molecules in a much greener way. And this also we have patented, and a patent has been granted also recently. So what we try to do that one, that is, water is one major environment around us. We should be very careful in not polluting the air as well as water. And one great pollution from the pharma industries or pharmaceutical manufacturing processes coming, particularly use of the volatile organic components. For that, we need to go for a replacement, and water has been project as a replacement. What we try to add on over there, apart from simply using water as a greener replacement the classical organic solvent, can you extract certain new chemistry through water? And towards this end, we have given a philosophy in water assisted reaction which we call amphiphilic, means electrophile nucleophile dual activation through cooperative hydrogen bond, which is a conceptual advancement in understanding the aqua chemistry and its rational use. If you try to do a search for that one, dual activation water mediated, the first 2 examples will come our paper. That 2 examples I started with N-Block formation and Thaya-Michael addition reaction. Now we wanted to utilize. So what has been the concern? You see that over the last couple of decades, lot of novel chemistry development has been taken place. But what is the major concern? And so whatever the chemistry do, whatever the sciences do, is actually for the society. And only benefit of doing chemical research is the society, either in terms of pharmaceuticals or the material for that one. And pharmaceutical happens to be one major contributor to chemical research. So if that be the case, then we have to think about that one, that we do not have any adverse effect for that one. So to this extent, we found out that water mediated reaction. So that means when we make the pharmaceuticals, we should be careful that one, to make a product which is going to treat you should not make you sick for that one, and that is going to come by mismanagement of the solvents. And in this regard, water provides, and issue is coming for that one, that those are not being integrated to the real practice. So to that extent, we try to use whatever as an academic interest, we try to find out that how does water promotes the formation of the benzothiazole. We did it in practice, because that becomes a starting metal preparation via the water assisted benzothiazole, and that gives a lead molecules, anti-TBLs. We did find out a completely all water chemistry for a completely new process of ranolazine, and totally all water chemistry for luvulazole. Ranolazine is already approved drug. Luvulazole is expected to be the hot molecule in years to come, provided it gets the US FDA nod. And we did try to extract the double benefit of the nanocatalysis and aqueous media to generate a versatile pharmacophoric scaffold, which is called for platform technology. Once you have that pharmacophore, you can go to any drug molecule for that one. And that has been possible by the double benefit of the aqueous media and a nanocatalysis over here. Finally, sustainable chemistry or sustainable development is the key to development of any branches of sciences. And in the area of chemical sciences, the green chemistry is the savior for that. Modern life depends on the petrochemicals, and most industries, drugs and etc., based on the, and oils based on the chemical processes. But current processes or maybe a few years back processes of making those chemicals were not sustainable, and to make them sustainable in a resource generation manner and the environmental impact manner, green chemistry aims to tackle this problem, and real progress has been made. Professor Sharma told you that for any new thing there is a lot of objection, and I have listened to him several times. I 100% understand his agony when he initiated. If there is a green chemistry, there has to be red chemistry, there is world chemistry. Similarly, moment green chemistry, people try to undermine that, oh, acha, you want to replace diethyl ether by water. It is not simply like that one. At the heart of green chemistry is innovation and the discovery of new chemistries, and not merely the incremental improvement of traditional synthetic methodology. The word green in green chemistry refers to fresh, young and new, has been told by father of green chemistry, Professor Paul Anastas, who was referred repeatedly by Professor Sharma. And I think by giving those examples, I tried to put before you that no, it is not simply replacing diethyl ether or dioxin by water. Why we are using water as a reaction media, why you are using nanocatalysis for that one. I have not talked about the ionic liquids. We have a different way to use ionic liquid in a greener way for that one. It was beyond today's agenda. I didn't talk about this one. So it is the fresh, young and new. And I thought that one that I'll try to give message to the young researcher, particularly younger colleagues. There is enough scope for you also to contribute to the green chemistry initiative, whatever the smallest we are doing. And unless or until we try that one, that it is not going to be that much fruitful in the future to come. All the work I have done in Naipur, I have superannuated from Naipur last year in November and shifted to nearby IIT around 40 miles away from Mohali or Chandigarh as a visiting professor for that one. I am yet to set my laboratory over there. It is under process for that one. Naisargi is in USA. She actually developed that S-DOS mediated water for that one. Kopil is done the reaction on the nanocatalysis. Basically, he introduced the nanocatalysis culture in my laboratory. Dinesh, he is in Naipur, Ahmedabad, faculty member. He also did a lot of ranolazole chemistry. He did it for that. Brahma, he also contributed a lot of catalysts. I didn't talk about that one for the beta blocker synthesis for that one. He is in industry. He is a big boss, I guess, for that one. And Sudipta, he is a faculty in IIT Delhi. He did a different way of ionic liquid research in my laboratory, but I didn't have a scope to talk about the ionic liquid. So it was my pleasure to discuss under the COVID situation and be active a little bit academically. And for that, I thank Pankaj and his colleagues to invite me. And thank you very much that you took some time and listened to me. I'll be very happy to attend to any of your queries.
Thank you, sir. Thank you so much for the wonderful presentations, which is very informative and beneficial for our listeners. If anyone has any query, you can ask or message us in chat box. The queries are welcome. No. Thank you, sir. Thank you for giving your valuable time. Now, in continuation, we would like to invite our another subject expert, respected Dr. S.K. Sharma, sir, who is retired associate professor, who is ex-HOD of Department of Chemistry, Bareilly College, Bareilly. He is ex-member of RDC MJPRU Bareilly. He is the ex-member of EC MJPRU Bareilly. He is life member of ICC. His research work on coordination, chemistry and bio-inorganic field. एंड इसके अलावा आपने बरेली कॉलेज में और एमजेपी रोहिलखंड यूनिवर्सिटी में अपनी बहुत सी सेवाएं दी हैं, जिसमें आपका जिसका आप बरेली कॉलेज और एमजेपीआरयू में आपका बहुत बड़ा योगदान रहा है. थैंक यू सर, एंड यू आर मोस्ट वेलकम इन आवर वेबिनार. प्लीज कम एंड ग्रेटिट्यूड अस बाय योर स्पीच. रिस्पेक्टेड प्रोफेसर S.K. Sharma, sir. Sir, please unmute your speaker. सर अपने स्पीकर को अनम्यूट कर लीजिए प्लीज.
हेलो.
यस सर. यस सर. गुड नून सर.
गुड नून.
First of all, I would like to thank the organizers for inviting me to have an interaction with the dignitaries of green chemistry, specifically Dr. Yadav, Dr. Sharma, who are the legendary personalities in the green chemistry. They are present here. Professor Chakravarti has just finished and given you too much informative knowledge about green chemistry, what its role. First of all, I like to thank Dr. Shashi Irati, Managing Director, Dr. Anil Sharma, Director, Dr. Doresh Chandra ji, Principal, and none other than Dr. N.K. Gupta, Secretary, who have given me opportunity to interact with you all. You have just listened Dr. Sharma, Dr. Yadav, and Dr. Chakravarti. So much has already been given to you regarding green chemistry. I will just give you a different approach towards it. In fact, after retirement, I have been a thinker also and an observer also. What I feel, this green chemistry, or the word green, is not fascinating only. It has got a meaning. It is related to our life even. Once we talk about green chemistry, then we talk about every aspect of our life, because chemistry is involved in our day-to-day life, whether it is kitchen for the housewives or any other part, that is our gardening or any other way we are doing anything. In fact, in our mythology, Gita is a holy book, and one of its principles is that whatever you do, you get something in return. So is with the chemistry. Whenever any chemical reaction is there, a product will be formed. Something or the other, you will get it. Even in our human body, internally, whatever we take is utilized for building up our cells, body cells, and the waste is gone outside. Waste is generally produced along with the products. Now, our green chemistry provides us the way that how can we reduce the waste and may produce the maximum product. So is the concept of this green chemistry. And with this point of view, I'll let you know that green chemistry or sustainable chemistry is a concept of rather than a new science. This concept, however, covers the consumer expectations in a sustainable environment and the efforts of the chemical industry to manufacture and supply useful products that are harmless and environmental benign. The green chemistry concept does not create a conflict between fossils and renewable raw material. It does, on the contrary, to preserve valuable but limited fossil resources and further investigate the potential of renewable biomass. Precisely in this sense, green polymer chemistry is to be understood for the world of plastics and biopolymers. Green chemistry, also known as sustainable chemistry, is among other things the design of chemical products and processes to prevent potential pollution sources and use renewable materials. This is also include avoiding potential environmental contamination via spills, leaks, and other type of accidents by using environmentally friendly materials. The risk for contaminating the environmental is substantially reduced if an accident should occur. It is for this reason that it is important to develop a green ideology and methodology than pursuing the synthesis of compounds. Regarding this, as earlier speakers told you, that there are 12 goals of green chemistry. It is designed of product and manufacturing processes to reduce the impact on human health and the environment. Fundamentals to the green chemistry concept is the idea of sustainability, reducing environmental impacts and conserving natural resources for future generations. Although many of the principles of green chemistry are not new, the extent to which they have been organized into a coherent approach and the degree of which they are being applied have resulted in intensified attention on this topic among the academic, industrial, and regulatory systems. The principal guidelines of green chemistry are intended to fulfill the following goals for any chemical process, whether industrial or laboratory scale. That is, to make a better use of available resources for the development of chemical processes. Secondly, to reduce the waste generated in any preparation or handling of chemicals. Materials should be prepared by improved processes that reduce the unwanted effect on the environment. Next, they replace toxic reagent and products with other that have same properties and applications but have less impact on the environment. Reduce the energy requirement to produce the substances of interest. Then reduce the energy required to produce substances interest either by the use of much faster processes, by the use of renewable energies involving lower energy cost with the equal efficiency, and the reduce toxicity or general danger for a given compound, substance, and the compound itself. Reduce cost by eliminating any manipulation that is not strictly necessary and decreasing time invested in the preparation of the substance. Encourage all the necessary actions to use chemical compatible with sustainable developments. We see it that the pollution is generated whenever there is a product is there. Regarding it, I will give you some examples for that. That whenever we undergo any organic chemical reactions, organic solvents we use, and for that we use organic solvents. Now replacing these organic solvents by water or ionic solvents that may decrease the pollution level and that may increase the productivity as well. One part of the green chemistry is how to reduce the atom economy of a chemical reaction. Now, what is atom economy? Atom economy, when the reactants, they are reacting to produce the product, then the number of reactants used, they define the atom economy. If lesser number of atoms are required, lesser number of molecules are required, then that means that atom economy is there. Atom economy may be best illustrated by the synthesis of ibuprofen. Ibuprofen, an analgesic, you all people know. Normally, in classical method, this ibuprofen was used to be prepared in 12 steps. But today, by using the green chemical processes, it is prepared in 6 steps. And its percentage atom utilization, which is calculated, found to be 27% in the earlier processes or the classical process, whereas by using the green chemistry or green process, the greater yield is obtained, that is, the atom economy rate is 77%. Now you may ask that what is this percentage atom utilization? Percentage atom utilization, that is the molecular weight of the final product divided by the sum of the molecular weights of the reactant into 100. That will give you that if it is greater in any chemical reaction, if you are undergoing, it is more than the previous one, then it means that the new reaction that is more beneficial, that is atom economical. Similarly, I went through the literature and found that the growth of marine organisms such as barnacles, algae, plants, and diatoms on the surface of ships hull, they create additional drag on the ship when it moves, and this additional drag costs the shipping industry over 3 billion per year in increased fuel consumption. In addition, no increased fuel costs, additional fuel consumption also leads to increased air pollution and wasteful use to fuel. A non-renewable resource, a buildup of these organisms can also cause increased dry dock and cleaning time, which costs the shipping industry about $2.7 billion a year. Thus, anti-fouling agents are used on boat hulls to reduce the buildup of these organisms. Now, the anti-fouling agents which were used earlier, they were normally having the tributyl tin as a main ingredient, whereas later on it was found that anti-fouling agent having isothiazolene and anti-fouling agents having isothiazolene that is better, although it is less persistent, but it is also, its actual concentration is less toxic to the nearly environment. We see that likewise these green reactions or green chemistry, how does it help? I see in the coastal side of Gujarat, there are so many solar panels. For the first time, I observed that what a change can be brought by using the natural resources and reducing the environmental pollution. There, through solar panels and windmills, the electricity is being produced and the classical methods, they have been installed. This is one way we see. I think our Prime Minister, Mr. Modi, is not only a statesman, but also a visionary, that he has started to promote these solar energy systems for the youth, which will certainly a greener way. In fact, the green chemistry or word green itself is self-explanatory. When a person is happy, he is green. We say, wherever positive thoughts are there, that is green. Greenery of the person concerned. Negative thoughts, that is the waste. That is how it is applied to our life day to day. Besides that, I can say that since much have been told regarding this, I will give you a nutshell, condensed principle of green chemistry, particularly for students and those who want to learn or know or remember it easily. What are the goals? And that the simple way, that is productivity. Productivity, the spelling of which is P-R-O-D-U-C-T-I-V-E-L-Y. Productivity. Now, in this productivity, P is to prevent waste. Regarding these are the condensed principles. Easily we can understand it that P is to prevent waste. R for renewable materials. O for omit derivation steps. D for degradable chemical products. U for use safe synthetic methods. T for temperature, pressure, ambient. I for in-process monitoring. V for very few auxiliary substances. E factor, maximize feed in product. L, that is low toxicity of chemical products. And Y, yes, it is safe. Means any chemical process which involves lesser steps, which involves lesser byproducts, waste material, that is green reaction or a part of green chemistry. In fact, it is no way any other branch of chemistry, but it is a concept within the chemistry. Any chemical reaction, whether it is inorganic or organic, whatsoever, if we have utilized or we have discovered a process in such a way that it is giving the maximum product and minimum waste, then it is a part of green chemistry. In day-to-day life, we all can be a part of green chemistry when we use different chemical reactions which undergo anywhere, whether it is waste. Every house has a waste, but if this waste is properly recycled or can be made usable, that means it is a part of green chemistry. So, in nutshell, the last I like to say only that don't think that it is confined to the chemists only. This green chemistry is for all. All of us can contribute towards it, but by utilization of such processes, such reactions, by which we can minimize the waste, so as to reduce the pollution of air or reduce the pollution of water. You have just seen during this lockdown period, in nature, there was such a purification. Pollution was reduced to that extent that which was never seen earlier. And this indicates that if by any way we impart lesser waste in the atmosphere, that means we are contributing for the green chemistry. With these words, I like to wind up my words. Thank you for calling.
Thank you, sir. Thank you so much for your lecture, which is very beneficial and informative for all of us. If anyone has any queries, he or she can ask or message us. Okay. Thank you, sir. Now, last but not the least, I would like to invite our next subject expert, respected Dr. Prajesh Singh Yadav, sir, who is Assistant Professor in University of Information Science and Technology, St. Paul the Apostle, Ohrid, Republic of North Macedonia. He works as Assistant Professor and works as visiting researcher at International Center for Genetic Engineering and Biochemistry, Trieste, Italy. He works as visiting scientist at Tel Aviv University, Israel. You have got so many scholarships and grants as FEBS Transcontinental YTF Award in Italy in 2018, NPDF grant by Department of Science and Technology Board, India, the PBC Fellowships for Outstanding Postdoctoral Researchers from China and India. You have 31 research publications. You have written 3 book chapters, and you have 4 popular articles. You delivered 5 lectures approximately, and 7 workshops you attended, and 8 posters you have presented. You have the membership of professional societies as European Biochemical Society, American Society of Plant Biology, International Society for Applied Life Sciences, and International Association of Engineering. We most welcome you, sir, in our webinar as the resource person of today's international webinar. You are welcome, sir. Good afternoon.
Thank you so much. Now I am going to connect my presentation.
Okay, sir.
Just a moment. Present now. Window. Okay, so you can see my presentation.
Yes, sir.
Okay. So, respected professor, dear teachers, and dear students, good afternoon, all of you. First of all, I would like to thank the Ganga Singh Mahavidyalaya and my dear friend Kuldeep and Pankaj ji who invited me on this prestigious webinar. as you know, like she already introduced about me, I am Dr. Vijay Singh Yadav. Presently, I am working as assistant professor. I am not the chemist. I am working in area of like bioinformatics. I am the bioinformatician. But last 6 years, I am working on the plant biochemistry. In the today topic, I am going to take the tool about the more greenery part, how these plant metabolites are going to help in the control the environmental pollution. So in this presentation, I put some of my research as well as some the common topic of the phytoremediation, where the plant are used to control the environmental pollution. So today topic I have divided in the 4 part. The first part we are going to see what is the effect of the environmental stress on the plant physiology. Then we are going to see the mechanism of the plant, how they are fighting with this environmental stress. And during this stress, they are going to secrete, they are going to synthesize some kind of the biochemicals, and these biochemicals provide the extra power to plant to fight with those environmental stresses. Then afterwards, we can use the more transgenic plant to use those chemicals, which help us to clean up our environment. So I am not going to discuss in detail about the pollutant, because you already know what is the pollution and what is the pollutant. And because we know there are a lot of now these days people are using the pesticide, they are using the different kind of the chemicals to enhance the production of the crop. On the other hand, this kind of the pesticide is very harmful for our soil, for our atmosphere, and in the ecosystem. This plant had to cope with those kind of the pesticide, those kind of the pollutant every day. Same times, plant also facing the adverse temperature fluctuation. They are facing some kind of the UV radiation. So this kind of the stress, environmental stress, either the chemical stress, they can stop the growth in the development of the plant. So likewise, we are the human being, either the animal, they can change their place, either they can move from one place to another place, but in the case of the plant, they had to fight with those kind of the stresses. So here you can see there are some kind of the atmospheric pollutant, like some kind of the gases. We have carbon dioxide, we have sulfur dioxide, we have the ozone. Then inside the soil, we have lead, we have the copper, we have the mercury, kind of the heavy metals. Then we have some kind of the potassium and the nitrogen, which can create the reactive oxygen species inside the plant. So these reactive oxygen species, they can damage some kind, many mechanism of inside the plant. So to see this mechanism, like we do one experiment. I am going to explain this experiment one by one, so you can understand this mechanism. So, like I told you, in the part of the phytophysiology of the plant, either they have to avoid the situation, either they adapt to the particular stress with a dose-dependent mechanism. Like if under the certain condition, if dose is mild, then plant can survive easily. But if the dose is going to be high, then plant start secreting some kind of the specific chemical to fight with those kind of the stress. For this work, we have collaborated one of the scientists in the Germany. He do the experiment on the plant, and he reproduced their data on the NCBI. So we utilize those data. These data contain 8 different kinds of environmental stress. they have the heat, wound, UV, genotoxic. Genotoxic, that means the pesticide and the other chemicals available in the soil. Then they have the drought, salt, osmo, and the cold stress. And they also give this stress in the 6 different time point. You can see in this picture. Point like half an hour, then after then 1 hour, then 3 hour, then 6 hour, then 12 hours, and last is 24 hours. After that, they can see which kind of the genes, either which kind of the biochemicals are secreted during this stress condition. So if you see this data, there are more than 2 million of the data points. As a like the data scientist, it was like my task to handle with those data. Here you can see the experimental setup of the experiment. We have the plant, then we give the environmental stress, which I already mentioned, and afterwards we see the gene expression, how the gene express during those stress conditions. It is not only the plant, even the any kind of the animal, either human being, once they get some kind of the stress, so their physiology going to be changed. Some genes are going to be expressed in higher condition, some are going to be down expressed, and after all, they are going to change the cellular metabolism inside our body, because our body want to resist those kind of the stress. So here you can see the different kind of the pattern of those environmental stress. Like if there is cold stress, that means if there is a like temperature is very cold, then this stress effect after 6 hours, you can see here after 6 hours, and some stress they start very early. In case of like the osmotic and the salt stress, if there is a lot of salt in the soil, then the plant root they start to getting sense those chemicals very early. And here in the bar you can see the number of pathway. So the blue color represent the lower number of the pathway, and the red color represent the higher number of the pathway during those environmental stress. Also the same here you can see what is the correlation between the different kind of the environmental stress. And here you can see the osmotic and the salt stress, they are grouped together. Also the heat stress, they are grouped alone. And especially the genotoxic stress, they are separate alone, because genotoxic contain a lot of heavy metals inside the soil. So then we just see which kind of the pathway, the molecular pathway which are involved in those environmental stress. So in this diagram we can see there are some kind of the RNAs, amino acids, hormones, signaling pathway, then plant secondary metabolites, lipid, and the carbohydrate pathway involved during this stress period. And today talk we are going to more focus about the secondary metabolites, because these are the chemicals which provide the extra power to the plants to cope with the environmental stress. So in this picture you can see the how this pathway specific induced pattern inside the plant. Like in first picture you can see the osmo and the salt and the genotoxic. This kind of the environmental stress is first start with the plant root, then they went up to the shoot. But some other stress like the cold and the wound, they start with the plant shoot and they come back to the root. So these are the chemicals, especially the early hours during the environmental stress can start to synthesize in very early stage. Then they initiate to synthesis of the many kind of the carbohydrates and the lipid. Ultimately, they are going to form glucosinolate, flavonoids, isotenoids, kind of the secondary metabolites, which are very essential chemicals which fight with the environmental stress. And we can also do the network analysis of those kind of the pathway, and we see the plant root have the different different kind of the chemicals, and the plant root have the different other kind of the chemicals. Like both the shoot having the aliphatic chemicals, aliphatic glucosinolate, and the root have the indolic kind of the glucosinolate synthesis during this environmental stress. Here, this is the mechanism. We can see the environmental stress on the plant. Then the plant receptors, they can sense those environmental stress. They start to giving the signal to the through the calcium and the receptor like kinase, where the some kind of the hormones, they start to initiate to RNA transcription factor. These all come under the primary response. They are start very early, like you can say like the 3 hours. Then after that, they initiate the metabolism of the amino acids inside the plant, and the amino acid metabolism are start to synthesis of the secondary metabolites, which are the ultimate goal of the plant. So these plant secondary metabolites, it relate plant with the component of their ecosystem, that is the physical environment and the living community. So thus resulting crucial for the survival of the species. So only these chemicals provide the extra power to the plant to fight with the environmental stress. So this stress metabolism is regarded as the particular expression of this kind of the secondary metabolites. And the plant are sessile habitat, so they are unable to avoid the worsening environmental condition. So plant have evolved an numerous number of secondary metabolites to overcome any kind of the danger for most of these specific chemicals. So once we know which kind of the gene either pathway involved in to fight with the environmental stress, we can identify those genes, and we can make use the genetic engineering, and we can make the more transgenic plant, and those plants are able to fight with the environmental stress. Here in this picture, you can see the traditional technique of the genetic engineering. Now this day it is very easy. Now we have the CRISPR-Cas9, so we can do very fast, and we can make the more transgenic plant which are able to clean our environment. So there is a terminology, you use the phytoremediation, and this phytoremediation where we are going to use the living plant to clean up the soil, air, and the water contaminant with the hazardous contaminants. And these kind of the plant are very cost effective, and they are the natural environmental remediation. And generally this kind of the plant have ability to concentrate the element and the compound from the environment to the detoxify the various compound. During the because of this concentrating effect, the ability of the certain plant are the hyperaccumulator to the bioaccumulator chemicals. And this sometimes like the toxic heavy metal cannot be degraded by this kind of the plant, but for sure the organic pollutant can be degraded through this phytoremediation technique. So you can see there are few kind of the terminology used in this phytoremediation. One is the phytodegradation, where the plant has destroyed the organic pollutant. Then phytovolatilization, it is the conservation of the metal and the metalloids to less toxic and the volatile form by the plant. Then we have the phytoextraction, where the metal are going to solubilization process. So this metal can cause the oxidative stress in the plant. Sometimes they destroy the cell membrane and they interfere with the nutrient uptake. And now this kind of the technology has been increasingly investigated and employed the many sites where the soil is contaminated by heavy metal like the cadmium, lead, aluminum, arsenic, and the antimony. Also, plants such like the Populus nicotiana tobaccum, they are genetically engineered to overexpress with some kind of the chemical like glutamate cytine to enhance the heavy metal accumulation as compared with the corresponding wild type of the species. So higher biomass hyperaccumulator are already developed, including the Indian mustard, we call sarso in our language, sunflower, tomato, and the yellow poplar. So on the conclusion of this presentation, we can see the simple presentation of the pathway of the cellular response during the environmental stress and how these different kind of the secondary metabolites are going to synthesize during this environmental stress. And once we recognize the gene which are regulate the release of the secondary metabolites, you can use those genes and we can make more genetic crop, either genetic plant, which are help to the plant to fighting with the stress, as well as we can make the phytoremediation using the living plant to clean up the soil, air, and the water, contaminate with the hazard condition. And the future goal is we can develop more transgenic plant to clean our environment. You can see here some of the publication which already published in some kind of the prestigious journals. And the last, thank you all of you listening me, and thanks for all of my lab member and the Tel Aviv University who continuously supporting me to doing this kind of the project. So I guess you can hear me properly. Yes, without any interruption.
Yes, sir.
Thank you so much. If anybody have any question regarding how the plant can clean up the environment, they can ask me.
Okay. If anyone has any questions, you can ask.
Yes, ma'am. Can I ask a question?
Yes.
Yes.
Yes, Sonam.
Yeah. Good afternoon, sir.
Good afternoon.
So, like your technique at photoremediation, and I am a teacher in class 12 and teaching chemistry.
Okay.
And I want to know, can I use this photoremediation technique as a chemistry project for my student?
Yeah, sure. Because these days, like this green chemistry, photoremediation, these are the maybe after 5-10 years we can see they have a good future. So it's good, like we can start this kind of education from the 12th level, either the degree level, so students have more awareness about this kind of the technology.
So which plant I should use, and how I can be able to justify that yes, this plant is working on it properly?
So like first we do the research, we see what is the effect of the plant. Like you can see in my research, we can see which kind of the genes are able to get to synthesis of some kind of the biochemicals that there is a one thing लोहे को काटता है. So this kind of the biochemicals which like we can incorporate those genes and we can make the transgenic plant. Now you can see like this tobacco plant, tomato, as well as mustard plant. They are the more useful to make our environment like clean.
But sir, there is an air purifier plant, indoor plant that I say, that aloe vera plant is like, and money plant, they all are using as an air purifier.
Yes. They
plant वो कैसे, हाँ, तो वो जैसे मेरे पास एयर प्यूरिफायर प्लांट है, वो कैसे फोटो रेमेडिएशन में, मतलब फोटो रेमेडिएशन जो जैसे आपने कहा मस्टर्ड सीड्स प्लांट्स हो गए, टमाटो प्लांट्स हो गए, तो ये कैसे बेनिफिशियल होंगे?
You have some kind of misunderstanding. I am talking about the transgenic plant. because these plants we can easily grow in the lab. We can do some kind of the editing. We can put those genes. We can put some kind of the chemicals, so they can synthesize more chemicals. Okay, so actually I was talking about the transgenic plant, and the plant you are talking, they are the natural, you can say the phytoredemy. They have the capability to clean the environment. They can absorb some kind of the like CO2 pollutant, like some kind of the chemical inside the atmosphere. They already slow down their effect.
Yes. So for making that photoremediation plant, I have to prepare that plant in the lab. As you are saying that photo transgenic plant, we have to prepare in the lab so that their efficiency
Yes,
will be increased.
yes, exactly. So we can put those genes, those genes we can synthesize the metabolites, the chemicals, the more chemicals, so they can use this purpose.
So next thing I have to search it on that the materials is available in 12th class lab or not.
Yes, yes, there are a lot of material. There are a lot of material available on the internet. If you need extra material, you can write the email. I can send you like the basically. Again, I am bioinformatician, so most of the experiment I am doing like in the lab, inside the lab, and with the computer. And if you need something special about the phytoremediation, you can email me. I can send you the material.
Okay, because I'm searching for the new topics for my class 12 students for their project
It's
work.
good for the student. Yeah, I appreciate you. It's good for the student.
Yes. Okay, sir. I will send you my email ID in the chat box. Okay, sir.
Okay,
Thank you so much for taking my query.
If you just put my name, you will get my email ID.
Okay, sir.
Okay.
Thank you so much.
Thank you so much.
Thank you, sir.
Thank you.
May I ask a question, please?
Yes, sir.
Yeah.
Good afternoon, sir. And I am working in a school. So, and the concept of green chemistry, as you have said, is a completely new emerging concept, and it has to be promoted. It will be promoted in the coming 5-10 years is a different thing, but it must be promoted from the junior level in schools, right? So, is there any experiment? Is there anything which we can demonstrate or which we can ask them to find out or survey or anything at 9th and 10th level? Because 11th, 12th, they do have access, and even if we talk to them about higher levels, they do understand. But 9th and 10th is a very basic level. So, is there something which we can do for them?
See, likewise, now this kind of the technology we start using now. So whatever the syllabus, either the CBSE board, either the UP board, they had, I think they are very basics, and the student first they have to learn the basics. Once they come to the like the intermediate classes, either the graduation, they can learn this kind of the technology whatever we discussing now. So first we have to make their base very strong. Like every science, either it's like green chemistry, either bioinformatics, they are just only start from the basics. So we have to like make the strong, the strong very basics very strong. Then we can learn all those kind of the things. There is no problem. Like we can make one chapter. We can see the okay now this time because the this time this is the chemistry. This is the because they have to know the fundamentals of the chemistry. So also likewise here the Professor Sharma, either the other they can say more about these things because I am already left in 2012, so I am not more touched with the education system in our country. So they have the more idea and they can suggest better than me.
Thank you, sir. I think our listeners are satisfied with your answers.
Hello.
Thank you.
Hello.
Hello. Yeah. Who's this?
Yes, sir. I have a question to
Yes.
Hello. Yeah, sir. Thank you very much, sir, for your Abdul, sir, I have
hear properly.
Hello.
Hello.
I think there is any network problem.
Yes, I guess so.
Yeah, sir. So thank you so much, sir. Thank you for giving your valuable time to us. And now, in continuation, I would like to invite our Director General of our college, respected Professor Anil Sharma, sir, who is a mentor, our guide, and supports us like a guardian. We welcome you, sir. Please come and gratitude us with your kind words. Respected Professor Anil Sharma, sir. Sir, please unmute your speaker. Yeah, sir.
Oh, am I audible?
Yes, sir, you are audible. Good afternoon, sir.
Good afternoon. Good afternoon, everybody. Today's webinar on the subject green chemistry. It has been a wonderful deliberation from all the speakers. Honorable Chief Guest, Professor Yadavji, the keynote speaker, Professor R.K. Sharma ji, and wonderful resource person, Professor Ashish Chakravarti ji, then my own friend, brother, was a resource person today, Dr. S.K. Sharma ji, and Professor Brajesh Yadav ji. They all have contributed to the subject so well that a man like me, who is not a chemistry student, was very well interested in listening every word of the speakers, and that is the success of the speakers on the subject chosen. Well, always there has been a saying from my side, today is better than yesterday, and that my statement holds true for today as well, because this is the last webinar of this series. So I can say now we will not be having it tomorrow. So we can say this is the best. So I congratulate Dr. Amit and his colleague Kuldeep Kumar ji for doing it so wonderfully, and the very, very round speakers that they have brought, that has definitely enriched us, and our chemistry department has wonderfully done well. Friends, हम लोग एक बात सुना करते थे, पाकर वायु पानी शुद्ध, सिद्धार्थ बन गए गौतम बुद्ध। अगर हमें मिल जाए शुद्ध, हम भी बन जाए गौतम बुद्ध। एक बच्चों की किताब में कहीं कविता थी, बट दैट गिव्स ए वंडरफुल मैसेज। ये जो हमारा पर्यावरण है ये शुद्ध हो तो निश्चित रूप से हम प्रबुद्ध बनेंगे। तो जो आज का ग्रीन केमिस्ट्री का सब्जेक्ट है, क्योंकि केमिस्ट्री और कॉमर्स मेरा अपना विषय है, हम दो लोगों को पर्यावरण का प्रदूषण करने के लिए जिम्मेदार ठहराया जाता है। अच्छा है एक नया टर्म ग्रीन केमिस्ट्री, और हमारे यहाँ भी कॉमर्स में ग्रीन कॉमर्स आया है। ये जो ग्रीन का कंसेप्ट है, ग्रीन का मतलब ये हरा हरी है धरती रानी, तो ये हमारी जो प्रॉस्पेरिटी है इसको हम हरे रंग से ही देखते हैं। तो हमारा स्वच्छ भारत और ग्रीन भारत, क्लीन भारत, ये जो कल्पनाएं हैं ये हमको हरा भरा बनाए। हमारी केमिस्ट्री अगर ग्रीन केमिस्ट्री होगी तो बॉटनी डिपार्टमेंट की ओर से प्रारंभ होकर केमिस्ट्री डिपार्टमेंट तक की आज की हमारी वेबिनार की यात्रा यहाँ विश्राम ले रही है। मैं अपने विभाग की ओर से, अपने महाविद्यालय की ओर से अपने सभी विभागीय साथियों को इस बात के लिए बधाई देता हूँ कि सबने बहुत अच्छा प्रयास किया। और सबसे बड़ी बात यह रही कि हमारे सारे साथियों ने बड़े मनोयोग से अपने अपने विभाग की एक वेबिनार आयोजित की। तो ये जो आपका आज का कार्यक्रम है तो सस्टेनेबल डेवलपमेंट, सस्टेनेबल केमिस्ट्री, और क्योंकि मैन काइंड विल सस्टेन फॉर लॉन्ग, तो हमारी सारी जो स्थितियां हैं, कहा जाता है सृष्टि का सारे गामा यह है कि परमात्मा ने सबसे पहले सा का मतलब सागर में जरी सर्प बनाए, उसके बाद में रे का मतलब रेत पर रेंगने वाले सारी सर्प बनाए, और ग का मतलब है गगन में उड़ने वाले पक्षी बनाए, और उसके बाद माँ से मतलब मनुष्य बनाया। और इस मनुष्य बनने के बाद परमात्मा का ये सर्वश्रेष्ठ कृति कही जाती है बच्चों को इसके पास बुद्धि है, इसके पास सोच है। सर्वेश्वर दयाल सक्सेना कहते थे, मैं हूँ इसलिए मैं सोचता हूँ और मैं सोचता हूँ इसलिए मैं हूँ। ये हमारा जो कार्यक्रम रहा, ये हम लोगों की सामूहिक सोच की परिणति है और इस सोच के परिणाम निश्चित रूप से हमें अच्छे मिले हैं। मैं बधाई देता हूँ हमारे आज के सभी वक्ताओं को जिन्होंने अपने वैचारिक सद्भाव से हम लोगों को समृद्ध किया है। प्रोफेसर यादव साहब कितना गंभीर चिंतन करते हैं और कितनी बढ़िया उनकी डिलीवरी है। इक्वली गुड इज आर के शर्मा साहब, इक्वली गुड इज मिस्टर चक्रवर्ती। हमारे यहाँ जितने भी आज के जो फसल रहे, आर के शर्मा जी और हमारे ब्रजेश यादव जी, सबने आज के विषय का प्रतिपादन किया। और मैं फिर बधाई देता हूँ डॉक्टर शशिबाला राठी को, कि उनका जो एक विचार था, जो एक सोच थी, जो एक चिंतन था, उसको फलित होते आज हम लोगों ने देखा। मैं उन्हें इस बात के लिए निश्चित रूप से बार बार बधाई देना चाहूंगा। हमारे कार्यक्रम का संचालन सुप्रिया जी कर रही थी। सुप्रिया दिन ब दिन पहले से बेहतर करती चली जा रही हैं। उनको मेरा बहुत बहुत बधाई और आशीर्वाद। हम सब इस आयोजन से एक साथ जुड़े, इसके लिए सारे लोगों को मैं आभार भी व्यक्त करता हूं और अपनी ओर से आशीर्वाद भी देता हूं। धन्यवाद।
थैंक यू सर, थैंक यू सो मच फॉर योर ब्लेसिंग्स। और आप रोज हमें कुछ ना कुछ नया सिखाते हैं। आज आपने हमें सारेगामा का मीनिंग बताया, जो कि बिल्कुल यूनिक और बहुत ही अच्छा है। थैंक यू सो मच, थैंक यू सो मच। नाउ अब मैं आज के वोट ऑफ थैंक्स के लिए हमारे महाविद्यालय के रिस्पेक्टेड प्रिंसिपल डॉक्टर दुरेश चंद सर को इनवाइट करती हूँ कि वे आए और हमारे जो भी माननीय अतिथिगण हैं उनका वोट ऑफ थैंक्स उनके लिए करें, उनका स्वागत सत्कार अपने शब्दों से करें। रिस्पेक्टेड डॉक्टर दुरेश चंद सर।
धन्यवाद सुप्रिया मैडम। हमारा सौभाग्य है कि हमने एक वेबिनार पखवाड़ा 1 जुलाई को प्रारंभ किया था गंगासील महाविद्यालय में, और आज 17 जुलाई को हम अपना अंतिम जो कड़ी है इस पखवाड़े की वेबिनार की, वो रसायन विज्ञान विभाग के माध्यम से पूरा किया है हमने। और आज का जो विषय रहा है पर्यावरणीय और समुद्रीय प्रदूषण को नियंत्रण करने में हरित रसायन शास्त्र की भूमिका, एक बहुत ही महत्वपूर्ण विषय आज हमारे रसायन विभाग ने चुना। और उस पर चर्चा करने के लिए जो उन्होंने पैनल यहाँ पर बुलाया, वो निसंदेह एक बहुत बड़ा पैनल था, जिसको ग्रीन केमिस्ट्री या हरित रसायन शास्त्र की पूरी जानकारी थी। वो उसके मैं तो कहूँगा कि प्रेरणा थे, ग्रीन केमिस्ट्री को भारत में प्रारंभ करने वाले थे। और उनमें से हमारे जो मुख्य अतिथि रहे प्रोफेसर जीडी यादव साहब, जो फॉर्मर वाइस चांसलर रहे हैं आईसीटी मुंबई के, पद्मश्री अवार्ड हैं भारत सरकार के द्वारा। और आपका बारे में सुप्रिया अग्रवाल जो हमें जानकारी दे रही थी, वो इतना विशाल था, इतना बड़ा था, जिससे हमें यह ज्ञात हुआ कि भाई आपका कितना बड़ा कद है और कितनी महान विभूति आप हैं। और आज आप हमारे महाविद्यालय के इस वेबिनार से जुड़े, हमें गौरवान्वित किया, हमारे आतिथ्य को स्वीकार किया। हम सब धन्य हैं, गदगद हैं और आपके बहुत आभारी हैं। आपने कहा सर कि सस्टेनेबल डेवलपमेंट बहुत ही महत्वपूर्ण है और शायद इसी को ही ग्रीन केमिस्ट्री कहते हैं। इसके 17 गोल हैं और आपने बताया कि 2024 तक हम 5 ट्रिलियन इकोनॉमी का सपना देख रहे हैं। और जो ह्यूमन लाइफ है वो केमिकल्स से घिरी हुई है। और आज जो केमिस्ट्री है वो हम स्ट्रक्चर से फंक्शन की तरफ को जा रही है। आपने सेल्फ रिलायंट इंडिया की बात की, आपने आत्मनिर्भर भारत की बात की कि किस तरीके से हम जो रसायन हमारे इंडिया के अंदर प्रेजेंट हैं, उपस्थित हैं, उनका उपयोग कर हम सेल्फ रिलायंट हो सकते हैं, आत्मनिर्भर बन सकते हैं। और आपने कहा कि जो हमारी इकोनॉमी है वो क्रूड ऑयल पर बेस्ड है और 2054 तक कोई ऑयल जो है नहीं रहेगा। और आपने बताया कि 33% जो ऑयल कंजप्शन है वो आपके कंस्ट्रक्शन में इस्तेमाल होता है। बड़ी महत्वपूर्ण इंफॉर्मेशन आपने बताई। आपने कहा कि स्टैंडर्ड ऑफ लिविंग से जो एनर्जी की मांग है वो बढ़ रही है, और जैसे जैसे एनर्जी की मांग बढ़ती है हमें जो है जो हमारी कार्बन जो है हमारा उतना ही हम बढ़ता है, जो हमारे लिए नुकसानदायक है। आपने सोलर एनर्जी की बात की, आपने हाइड्रोजन बेस्ड इकोनॉमी की बात की, आपने बायोफ्यूल की बात की, आपने हाइड्रोजन मार्केट को बताया कि जिसका जो ट्रिमेंडस है, और हाइड्रोजन बेस्ड आपने इकोनॉमी की बात की। सर आप हमारे इस वेबिनार से जुड़े, हमें आपने अपने विचारों से अभिभूत किया, हमारे और सभी प्रतिभागीगण निसंदेह इससे लाभान्वित हुए। हम आपका बहुत बहुत आभारी हैं, बहुत बहुत आपको धन्यवाद देते हैं। बहुत बहुत आभार एवं बहुत बहुत धन्यवाद सर। हमारे आज के वेबिनार के जो कीनोट स्पीकर थे प्रोफेसर R.K. शर्मा जी, जो कोऑर्डिनेटर हैं ग्रीन केमिस्ट्री के और केमिस्ट्री नेटवर्क सेंटर के डिपार्टमेंट ऑफ केमिस्ट्री दिल्ली, यूनिवर्सिटी दिल्ली के, और आपने पूरी ग्रीन केमिस्ट्री को इतने सरल तरीके से और इतने सिस्टमेटिक तरीके से हमारे सामने रखा कि शायद एक ऐसा व्यक्ति भी जो बिल्कुल इसके बारे में न जानता हो, वो भी उसने भी बहुत कुछ सीखा है। आपने कहा कि किस तरीके से आज हम पॉल्यूशन से घिरे हुए हैं, और हमारा एनवायरमेंटल पॉल्यूशन है, हमारा जो है वाटर पॉल्यूशन है, इसके अलावा आपका जो है साउंड पॉल्यूशन है, यानी कि इतनी हमारी लाइफ पॉल्यूशन से प्रभावित है, और उसका एकमात्र सॉल्यूशन है वो है आपका ग्रीन केमिस्ट्री। और आगे आने वाले 50 सालों में हम ग्रीन केमिस्ट्री के माध्यम से अपने को बहुत अच्छा रख सकेंगे, अपनी स्टैंडर्ड ऑफ लिविंग को बढ़ा सकेंगे, और वो भी ऐसा स्टैंडर्ड ऑफ लिविंग होगा कि जिसके अंदर इस तरीके के केमिकल्स का दुष्प्रभाव ना पड़े। आपने कहा कि 1999 में जब हमने ये प्रारंभ किया था तो बहुत कम लोग थे जो इसकी तरफ ध्यान दे रहे थे, लेकिन आपने बताया कि किस तरीके से आपने महात्मा गांधी के विचारों से प्रेरणा लेकर इस ग्रीन केमिस्ट्री कंसेप्ट को आगे बढ़ाया, और आज निसंदेह ग्रीन केमिस्ट्री भारत की ही नहीं पूरे विश्व में इसकी पहचान बन गई है। और आज कोविड-19 के जो एक महामारी है, इसके संदर्भ में अगर देखा जाए तो ग्रीन केमिस्ट्री का अपना एक महत्वपूर्ण योगदान रहेगा आगे आने वाले समय में। सर आपने इतना सुंदर और इतना सिस्टमेटिक तरीके से इस बड़े विषय पर प्रकाश डाला, हम सबको लाभान्वित किया। हम आपके अत्यंत आभारी हैं, आपको बहुत बहुत धन्यवाद देते हैं, आपके तहे दिल से आपको शुक्रिया अदा करते हैं। हमारे जो सब्जेक्ट एक्सपर्ट रहे डॉक्टर A.K. चक्रवर्ती साहब, जो विजिटिंग प्रोफेसर हैं डिपार्टमेंट ऑफ केमिस्ट्री IIT रोपर पंजाब के। आप सर हमारे इस वेबिनार से जुड़े, और आपने बताया कि जो एनवायरमेंटल पॉल्यूशन है वो अगर देखा जाए तो वो केमिस्ट्री की देन है, और ई केमिस्ट्री जो केमिस्ट्री की एक ब्रांच है उसके माध्यम से हम इस पॉल्यूशन को जो केमिस्ट्री ने दिया है उस पर कंट्रोल कर सकते हैं। और इसके लिए आपने बड़ा बढ़िया तरीके से जानकारी दी ग्रीन केमिस्ट्री की। आपने बहुत सारे रिएक्शंस, केमिकल रिएक्शंस का उदाहरण दिया, और किस तरीके से आपने बताया कि जो वाटर सॉल्वेंट है, वाटर जो है, पानी जो है, वो एक बेस्ट सॉल्वेंट है, और कहें तो ग्रीन केमिस्ट्री में एक ग्रीन सॉल्वेंट है। तो आपने इस पर विस्तार से चर्चा की, और आप हमारे इस वेबिनार से जुड़े, हम आपके बहुत बहुत आभारी हैं सर, और आपको बहुत बहुत धन्यवाद देते हैं। हमारे दूसरे सब्जेक्ट एक्सपर्ट थे डॉक्टर S.K. शर्मा जी, जो पूर्व एसोसिएट प्रोफेसर हैं बरेली कॉलेज बरेली से। आपने बताया कि अगर हम खुश होते हैं तो इसका मतलब यह है कि हम ग्रीन केमिस्ट्री है। अगर हमारे अंदर पॉजिटिव थॉट्स आते हैं तो इसका मतलब ये है कि ये ग्रीन केमिस्ट्री है। और अगर हमारे अंदर नेगेटिव थॉट्स आते हैं तो ये एक वेस्ट प्रोडक्ट है जो हमारे अंदर नहीं आना चाहिए। आपने कहा कि गीता कहती है कि जो कुछ ईश्वर को देता है, ईश्वर कुछ ना कुछ अवश्य उसको वापस करता है। इसी तरीके से केमिस्ट्री में भी जब हम कोई भी केमिकल प्रोडक्ट बनाते हैं तो वो जो अच्छा बनता है, लेकिन उसके साथ साथ कुछ ना कुछ ऐसा टॉक्सिक सब्सटेंस भी बन जाता है जो हमारे लिए नुकसानदायक होता है। और इस टॉक्सिक सब्सटेंस को ही अच्छे पदार्थों में बदलना, यूजफुल पदार्थों में बदलना, यही एक ग्रीन केमिस्ट्री है। और आपने बड़े सुंदर तरीके से इसका वर्णन किया। आपने कहा कि ग्रीन केमिस्ट्री को सस्टेनेबल केमिस्ट्री भी कहते हैं, और आपने ऑर्गेनिक सॉल्वेंट की बात की, आपने वाटर सॉल्वेंट की बात की, आयनिक मेटल सॉल्वेंट की बात की, और आपने प्रोडक्टिबिलिटी के माध्यम से ग्रीन केमिस्ट्री को सार को समझाया। सर, आपने हमारा आतिथ्य स्वीकार किया, हमारे बीच आप उपस्थित हुए, समय दिया, हम आपके बहुत बहुत आभारी हैं, बहुत बहुत आपको धन्यवाद देते हैं। हमारे नेक्स्ट जो सब्जेक्ट एक्सपर्ट रहे, जिनकी वजह से हमारा यह वेबिनार इंटरनेशनल वेबिनार में तब्दील हुआ, डॉक्टर ब्रजेश सिंह यादव जी, जो असिस्टेंट प्रोफेसर यूनिवर्सिटी ऑफ इंफॉर्मेशन साइंस एंड टेक्नोलॉजी, सेंट पॉल द अपोस्टल, ओहरिट, रिपब्लिक ऑफ नॉर्थ मैसेडोनिया। आप सर बेसिकली एक बायोकेमिस्ट्री से ताल्लुक रखते हैं, और आपने बताया कि किस तरीके से एनवायरमेंट पॉल्यूशन प्लांट को प्रभावित कर रहा है। ग्रीन केमिस्ट्री सारी की सारी जो है ह्यूमन बींग्स को प्रभावित करने वाले से ताल्लुक थी, लेकिन आपने एक नया विषय उठाया कि भाई ऐसा नहीं है, एनवायरमेंट पॉल्यूशन से हमारे जो प्लांट्स हैं, जो फ्लोरा है, वो भी प्रभावित होता है, और वो किस तरीके से प्रभावित होता है, उसकी फिजियोलॉजी पर क्या प्रभाव पड़ता है, वो उस स्ट्रेस से बचने के लिए अपने अंदर कौन कौन से केमिकल्स पैदा करता है, क्या उसकी डिफेंस मैकेनिज्म होती है, क्योंकि पौधे भी लिविंग बींग्स होते हैं, उनको वो भी प्रभावित होते हैं। और आपने बड़ा बढ़िया कहा कि भाई ह्यूमन बींग्स है या कोई और एनिमल है, वो तो अगर कहीं कोई स्ट्रेस हो रहा है, कहीं कोई पॉल्यूटेंट हो रहा है, वहां से वो बाहर जा सकता है, अलग जा सकता है, उनको बचा सकता है। लेकिन पौधा तो एक ऐसा है कि जहां पर वो खड़ा हुआ है, जहां पर वो एस्टेब्लिश है, वहां से नहीं जा सकता, उसको तो उस पॉल्यूटेंट को झेलना ही पड़ेगा। और उस पॉल्यूटेंट को वो किस तरीके से जो है ओवरकम करता है, ये उसकी खासियत है। इसके लिए आपने कहा कि भाई फोटो रेमेडिएशन की आपने बात की, आपने फाइटो डिग्रेडेशन की बात की, आपने ट्रांसजेनिक प्लांट्स की बात की कि किस तरीके से हम बायोटेक्नोलॉजी के माध्यम से ऐसे प्लांट्स पैदा कर सकते हैं जो हमारे इस एनवायरमेंट पॉल्यूटेंट्स को दूर कर सकें, उनसे हमारी रक्षा कर सकें। तो ये भी एक बहुत इंपॉर्टेंट एस्पेक्ट है कि किस तरीके से जो है जो एनवायरमेंटल स्ट्रेस है, एनवायरमेंटल पॉल्यूशन है, वो फौना के साथ साथ फ्लोरा के ऊपर भी बहुत प्रभाव डाल रहा है, और इसको निसंदेह इस पर भी बहुत ध्यान देने की आवश्यकता है। आप सर मैसेडोनिया से हमारे इस वेबिनार में जुड़े, हमारे इस वेबिनार को सफल बनाया, और साथ ही साथ जो जिज्ञासाएं थी हमारे पार्टिसिपेंट्स की, उनको आपने जो है जिज्ञासाओं को पूरा किया। और यह जो वेबिनार रहा, इसके अंदर मैं देख रहा था कि इतनी जिज्ञासाएं आई कि भाई ये बायोकेमिस्ट्री, ये ग्रीन केमिस्ट्री उच्च शिक्षा के लिए ही नहीं है, बल्कि इसको जो है प्रारंभ से ही प्रारंभ किया जाए। जो हमारे पार्टिसिपेंट्स थे, उन्होंने एक ग्रीन केमिस्ट्री के प्रति रुचि दिखाते हुए यह दर्शाया कि क्यों न हम इसको बेसिक लेवल से ही अपने सिलेबस में रखें। और ये प्रोफेसर आर.के. शर्मा जी ने बताया भी कि भाई किस तरीके से उन्होंने यूनिवर्सिटी ऑफ दिल्ली में ग्रीन केमिस्ट्री को रखा है, और प्रयास कर रहे हैं कि नीचे अंडर ग्रेजुएट लेवल पर भी आए। तो ये वास्तव में एक बहुत ही महत्वपूर्ण टॉपिक है जिसको कि हम अपने सिलेबस में इनको इनकॉर्पोरेट करना चाहिए। तो ये सर आप सभी जो विद्वान वक्ता थे उन सबका मैं बहुत बहुत आभार और बहुत बहुत उनको धन्यवाद देना चाहूंगा। हमारे महाविद्यालय के महानिदेशक प्रोफेसर NL शर्मा सर जो हमेशा हमें इन गतिविधियों में प्रेरित करते रहते हैं, और जैसा कि हम और हमारे शिक्षक साथी उन्हें कहते हैं कि भीष्म पितामह हैं, रियल सेंस में वो भीष्म पितामह हैं जो हमें हर अवस्था में मार्गदर्शन करते रहते हैं। आपने कहा कि भाई केमिस्ट्री से चलता हुआ यह वेबिनार आज बॉटनी से चलता हुआ यह वेबिनार आज केमिस्ट्री पर आकर खत्म हो गया और एक बेस्ट वेबिनार था। तो ये मैं एक कॉम्प्लीमेंट्स है हमारे केमिस्ट्री डिपार्टमेंट को, मैं उनको निसंदेह अपने तहे दिल से बधाई देना चाहूंगा। आपने कहा कि पर्यावरण अगर शुद्ध है तो हम भी शुद्ध रहेंगे, हमें भी स्वस्थ रहेंगे, और आपने ग्रीन केमिस्ट्री के साथ साथ ग्रीन कॉमर्स की बात की, और ग्रीन कॉमर्स के साथ साथ आपने ग्रीन इंडिया की बात की। ऐसे हैं हमारे महानिदेशक साहब, आपका सर बहुत बहुत आभार, बहुत बहुत धन्यवाद। हमारे महाविद्यालय की प्रबंध निदेशिका आदरणीय विदुषी डॉक्टर शशिबाला राठी जी जो हमेशा से ही अपनी इन वेबिनार्स में रुचि रखती हैं, एक उनकी सोच है, एक चिंतन है, और आज भी फाइन आर्ट्स की स्टूडेंट होने के बावजूद भी हमारी इस ग्रीन केमिस्ट्री में उन्होंने रुचि रखा और बताया कि भाई किस तरीके से वो चिंतित हैं मेडिसिनल प्रोडक्ट से, वेस्ट से, प्लास्टिक वेस्ट से, इंसेक्ट से, पेस्टिसाइड से, कि वो किस तरीके से हमारे भोज्य पदार्थों में आ रहे हैं और हमें हमारे शरीर के अंदर जा रहे हैं, रोग पैदा कर रहे हैं। हम उर्वरक फर्टिलाइजर्स का उपयोग कर रहे हैं ज्यादा खेती प्राप्त करने के लिए, ज्यादा प्रोडक्टिविटी प्राप्त करने के लिए, जो कि हमें अल्टीमेटली हमारे स्वास्थ्य को नुकसान पहुंचाता है। और आपने मैडम जो यहाँ पर अपनी जिज्ञासा रखी, मुझे उम्मीद है कि हमारे विद्वान वक्ताओं ने, रिसोर्स पर्सन्स ने वो बड़ा डिटेल में विस्तार से चर्चा करके सभी जिज्ञासाओं को दूर किया। आपका मैडम हम बहुत बहुत आभारी हैं, बहुत बहुत आपको धन्यवाद देते हैं। हमारे महाविद्यालय के सचिव डॉक्टर NK गुप्ता जी जो हमेशा से ही इन गतिविधियों में रुचि रखते हैं और हमें प्रेरित करते रहते हैं कुछ नया करने के लिए। सर आप हमारे वेबिनारों से जुड़े, हम आपके बहुत बहुत आभारी हैं, आपके बहुत बहुत आपको धन्यवाद देते हैं। हमारे इस वेबिनार में मैं देख रहा था कि हमारे बड़े हमारे साथी जन इससे जुड़े विद्वान लोग जुड़े। डॉक्टर AK गोयल साहब जो इस महाविद्यालय के पूर्व प्राचार्य रहे हैं और पूर्व संयुक्त सचिव हैं उच्च शिक्षा के उत्तर प्रदेश सरकार के, वो प्रारंभ से ही हमसे जुड़ते रहे हैं और हमें गौरवान्वित करते रहे हैं, हमें प्रेरित करते रहे हैं। हम आपका सर तहे दिल से धन्यवाद देते हैं, आपका आभार व्यक्त करते हैं। हमारे आज के इस वेबिनार से डॉक्टर संजीव श्रीवास्तव जी जो प्राचार्य हैं सीतापुर में महमूदाबाद गवर्नमेंट PG कॉलेज में, हम आपका भी आभार और आपको स्वागत, आपका धन्यवाद देते हैं। इकबाल हबीब साहब भी हमारे इस वेबिनार से जुड़े जो प्राचार्य हैं फरीदपुर गवर्नमेंट डिग्री कॉलेज में। डॉक्टर निशा राघव, डॉक्टर RP राघव जो मॉडल टाउन बलिया से हमारे इस वेबिनार में जुड़े, हम आपके भी तहे दिल से आभारी हैं, शुक्रिया अदा करते हैं। डॉक्टर सहदेव जी गवर्नमेंट रजा कॉलेज रामपुर से जुड़े, आपके हम आभारी हैं। इसके साथ साथ हमारे इस वेबिनार से पूरे के पूरे इंडिया से, साथ में विदेशों से भी बहुत पार्टिसिपेंट जुड़े, विद्वान साथी जुड़े जिन्होंने इस वेबिनार को सफल बनाया और हमें यह प्रेरणा दी कि भाई किस तरीके से जो है अच्छा काम करने पर अच्छे लोग जुड़ते हैं और उससे लाभान्वित होते हैं। हम आपके तहे दिल से आभारी हैं, आपको बहुत बहुत आभार व्यक्त करते हैं, धन्यवाद देते हैं। सभी प्रतिभागियों को मेरा हाथ जोड़कर नमस्कार, और मैं चाहूंगा कि आगे आने वाली गतिविधियों में भी आप लोग इसी तरीके से हमें स्नेह देते रहें और हमसे जुड़ते रहें। हमारे आज की जो ऑर्गेनाइजिंग कमेटी है, हम उसको भी तहे दिल से शुक्रिया और धन्यवाद व्यक्त करते हैं। जो हमारे सचिव ऑर्गेनाइजिंग सेक्रेटरी रहे हैं डॉक्टर पंकज जी, जो विभाग अध्यक्ष हैं रसायन विज्ञान विभाग के, डॉक्टर कुलदीप वर्मा जी जो हमारे सह ऑर्गेनाइजिंग सचिव थे, उन्होंने बहुत ही अच्छा टॉपिक चुना था, बहुत ही अच्छे उन्होंने रिसोर्स पर्सन्स को यहाँ पर आमंत्रित किया और वो निसंदेह बधाई के पात्र हैं। उनका विभाग बधाई का पात्र है और मैं उनका महाविद्यालय की तरफ से आभार व्यक्त करता हूं और उनको बहुत बहुत धन्यवाद देता हूं। इसके साथ साथ संचालन कर रही सुप्रिया अग्रवाल जो गृह विज्ञान विभाग की अध्यक्षा हैं और निसंदेह उनके संचालन में एक बहुत ही निखार आया है और हम आगे देखते हैं कि वही और अच्छा वो करेंगी। उनको भी बहुत बहुत बधाई और साथ ही साथ उनको बहुत बहुत आभार और धन्यवाद। हमारे महाविद्यालय के सभी शिक्षक जो 1 जुलाई से लेकर आज तक जुड़े हुए थे वेबिनारों में और अपने अपने विषय से संबंधित वेबिनार को उन्होंने तैयार किया, एक से बढ़कर एक वेबिनार का उन्होंने आयोजन किया, सभी बधाई के पात्र हैं और साथ ही साथ मैं सबका आभार व्यक्त करता हूं, सबको धन्यवाद देता हूं। और हमारे ऑर्गेनाइजिंग कमेटी में डॉक्टर स्वाति, डॉक्टर प्रतिका, डॉक्टर तरुण पांडे, डॉक्टर अनिरुद्ध अवस्थी जी, इन सबका भी मैं तहे दिल से शुक्रिया और आभार व्यक्त करता हूं। और अंत में पुनः एक बार सभी हमारे विद्वान प्रतिभागियों का, सभी विद्वान वक्ताओं का और सभी का तहे दिल से बहुत बहुत आभार, बहुत बहुत धन्यवाद। सबको नमस्कार।
Thank you, sir. Thank you so much. Last, this is the last but not the least webinar of our webinar series conducted by our college Gangasheel Mahavidyalaya, Nawabganj, Bareilly. And मैं आपको बताना चाहूंगी कि हमारे आज के इस वेबिनार में नेशनल और इंटरनेशनल लेवल पर किस किस स्टेट से लोग जुड़े, जो है यूपी, उत्तराखंड, हैदराबाद, पंजाब, जम्मू कश्मीर, गुजरात, छत्तीसगढ़, मध्य प्रदेश, झारखंड, केरला, असम, तमिलनाडु, बिहार, तेलंगाना, राजस्थान, महाराष्ट्र, पंजाब, उड़ीसा, आंध्र प्रदेश, कर्नाटक, हरियाणा, त्रिची, गोवा, दिल्ली, कोलकाता, वेस्ट बंगाल। और इसके अलावा जो आउट ऑफ इंडिया दैट इज दुबई, फिलीपींस, नाइजीरिया से भी लोग हमारे साथ इस वेबिनार में जुड़े, जिन्होंने हमारे आज के इस इंटरनेशनल वेबिनार को सफल बनाया। थैंक्स टू ऑल ऑफ यू फॉर मेकिंग दिस वेबिनार सक्सेसफुल एंड thanks a lot to all the members, all the staff members of our college who supported us, who helps us in the conduction of this webinar. Thank you once again. And आपके पास फीडबैक लिंक भेजा जा चुका है, तो प्लीज अपने फीडबैक फॉर्म जल्द से जल्द भर के हमें भेजिए और जो आपके ई सर्टिफिकेट्स होंगे वो आफ्टर 20 जुलाई आपको भेज दिए जाएंगे। Thank you once again and have a nice day.